Hello there, you're listening to the planet's memory, where time breathes and the Earth remembers. Close your eyes and let your mind drift beyond the familiar boundaries of our world. Tonight, we embark on a journey that will carry you through the silent corridors of time, back to an era so ancient that even the stars themselves have forgotten its name. Imagine for a moment that everything you have ever known about the moon, that pale guardian hanging in our night sky, is merely the surface of a truth so profound it could reshape the very foundation of human understanding. What if the celestial body that has inspired poets, guided sailors, and pulled at our oceans for countless millennia is not a natural formation at all, but something far more extraordinary? What if the moon is an artifact, a monument left behind by the first civilization, a civilization so advanced that their technology appears to us as the work of nature itself? Let this possibility wash over you like a gentle wave as you settle into the comfort of this moment, allowing your breathing to slow and your thoughts to drift into the realm of cosmic mystery. The night sky has always been humanity's greatest canvas for wonder, and among all the celestial objects that dance across the darkness, none has captured our imagination quite like the moon. Since the dawn of human consciousness, we have looked up at that luminous disk and created stories, myths, and legends to explain its presence. Ancient cultures saw in its face the features of gods and goddesses, while others believed it to be a gateway to other realms or a home for departed souls. But what if all these stories, these intuitive feelings that the moon is somehow special and somehow different from other natural objects, contain a kernel of truth that modern science has only begun to uncover? What if our ancestors, in their wisdom, sensed something about the moon that our logical, rational minds have dismissed as mere superstition? Tonight we will explore a possibility that exists at the intersection of ancient mystery and modern discovery, a possibility that suggests the moon is not what we have been taught it is, but rather the greatest archaeological find in human history, waiting patiently above our heads for us to finally recognize it for what it truly is. The story we are about to unfold is not told in the language of certainty, but in the whispers of possibility, in the questions that arise when we examine the known facts about our lunar companion and find that they do not quite align with what we would expect from a naturally formed satellite. This is a story that asks you to suspend your preconceptions and consider that the universe might be far stranger and more wonderful than even our most imaginative scientists have dared to propose. As you lie here in the darkness, allow yourself to become weightless, to float free from the constraints of conventional thinking, and to drift alongside us through corridors of time that stretch back not thousands or even millions of years, but billions of years into the deep past, to an age when the solar system was young and vibrant with possibilities that no longer exist in our current cosmic neighborhood. Let the questions we raise tonight lull you into a state of peaceful contemplation, where sleep and wonder merge into a single stream of consciousness, carrying you gently toward rest while simultaneously expanding your sense of what might be possible in this vast and mysterious universe we call home. The moon is strange, far stranger than most people realize, and once you begin to examine its properties with a critical eye, you discover a series of coincidences so remarkable that they seem to defy the normal patterns we observe throughout the solar system. Consider first the most obvious and yet most overlooked fact about our moon, which is its apparent size in our sky. When you look up during a solar eclipse and watch as the moon slides perfectly across the face of the sun, blocking its light with such precision that only a ring of fire remains visible around the edges, you are witnessing a geometric coincidence that should give any thoughtful person pause. The sun is approximately 400 times larger than the moon, and by pure chance the sun is also approximately 400 times farther away from Earth than the moon, creating a situation where both objects appear to be almost exactly the same size from our perspective on the ground. This precise ratio exists nowhere else in our solar system among the dozens of moons and planets that we have observed and studied. From a statistical standpoint, the probability of this occurring by random chance is extraordinarily small. Yet here we are, living on the one planet where this perfect cosmic alignment exists. Scientists who work within the conventional framework of planetary formation acknowledge that this is a remarkable coincidence, but generally dismiss it as nothing more than that, a lucky accident of celestial mechanics that makes for spectacular solar eclipses, but holds no deeper significance. But what if we approach this fact from a different angle? What if we ask ourselves what would be required to intentionally create such a perfect alignment? And more importantly, why an advanced civilization might choose to do so? If you were an ancient engineer tasked with placing a massive object in orbit around a planet, and if you wanted that object to serve as both a functional device and a symbolic marker, you might very well position it at precisely the distance necessary to create these perfect eclipses, using the phenomenon as a kind of signature, a way of announcing to any future intelligent species that develops on the planet below that something unusual is present in their sky. The size of the moon relative to Earth is another anomaly that stands out when we survey the solar system. Our moon is proportionally huge compared to the size of its parent planet, so large that some astronomers prefer to think of the Earth-Moon system not as a planet with a satellite, but as a double planet system, two bodies of significant size locked in a gravitational dance. Most moons in the solar system are tiny compared to the planets they orbit, mere captured asteroids or small bodies that formed from the leftover debris of planetary creation. Mars has two minuscule moons that are clearly captured asteroids, irregular in shape and insignificant in mass. The gas giants have dozens of moons, but even the largest of these are small compared to the enormous size of Jupiter or Saturn. Earth, however, a rocky planet of modest size, has a moon that is more than 1/4 its diameter, a ratio that is unique among the terrestrial planets and unusual even when compared to the entire catalogue of known planetary systems throughout our solar system. The conventional explanation for this unusual size relationship involves a catastrophic collision early in Earth's history, a theory that has become known as the giant impact hypothesis. According to this model, approximately 4.5 billion years ago, a Mars-sized object that scientists have named Theia crashed into the early Earth with tremendous force, and the debris from this collision eventually coalesced to form the Moon. This theory has gained widespread acceptance because it can explain many of the Moon's properties, including its size, its composition, and its orbital characteristics. Computer simulations of such an impact do indeed show that a moon-like body could form from the resulting debris field, and analysis of lunar rocks brought back by the Apollo missions shows that the moon's composition is remarkably similar to Earth's mantle, consistent with the idea that much of the moon's material came from Earth itself during this catastrophic event. However, like many scientific theories, the giant impact hypothesis raises as many questions as it answers, and some of the details do not quite fit as neatly as we might hope. One of the puzzling aspects of the moon's composition is that it is too similar to Earth in some ways, and too different in others. The ratio of certain isotopes in lunar rocks is nearly identical to those found in Earth's mantle, which the giant impact hypothesis can explain. But other aspects of the moon's chemistry suggest that it should have retained more material from the impacting body, Theia, than we actually observe. If the collision happened the way the simulations suggest, we would expect the moon to be a mixture of material from both Earth and Theia, yet the chemical signature of this hypothetical impactor is strangely absent or greatly diminished in the samples we have analysed. Some researchers have proposed modifications to the original impact scenario to account for these discrepancies, suggesting perhaps that the collision was even more violent than initially thought, creating temperatures high enough to vaporize and thoroughly mix the materials from both bodies. But these explanations require increasingly specific and unlikely conditions, stacking coincidence upon coincidence to make the theory work. Another peculiarity that the giant impact hypothesis struggles to fully explain is the Moon's orbit. The Moon orbits Earth in a roughly circular path that lies almost perfectly in the plane of Earth's equator, or more precisely close to the plane of the ecliptic, which is the plane in which Earth orbits the Sun. This is unusual for a moon that supposedly formed from the debris of a massive collision, because such violent events typically produce debris fields that are chaotic and randomly oriented. We would expect a moon formed from impact debris to have a more eccentric orbit, one that is either more elliptical or more steeply inclined relative to Earth's equator. Yet the Moon's orbit is remarkably well behaved and regular. Over billions of years, tidal forces between Earth and the Moon have certainly modified the orbit, gradually pushing the Moon farther from Earth and causing its orbit to become more circular. But the starting conditions required for the Moon to end up in its current configuration still require a series of fortunate circumstances that strain the limits of what we consider probable. The internal structure of the Moon adds yet another layer of mystery to its nature. When seismometers were placed on the lunar surface during the Apollo missions, they recorded moonquakes and impacts that revealed surprising information about what lies beneath the Moon's dusty exterior. Unlike Earth, which has a large molten core that generates our planet's magnetic field and drives plate tectonics, the Moon appears to have a very small core, if it has one at all. And much of its interior seems to be less dense than we would expect from a body composed primarily of rock. Some of the seismic data suggested that the Moon might even be partially hollow, with large void spaces beneath the surface, though this interpretation is controversial and disputed by many lunar scientists. When a spent rocket stage was deliberately crashed into the Moon during one of the Apollo missions, the Moon rang like a bell for an unusually long time, with vibrations continuing for hours, a phenomenon that some researchers found difficult to reconcile with their models of a solid rocky body. The surface of the Moon presents its own collection of oddities that have puzzled observers for centuries. The dark patches that form the familiar face we see when we look at the full Moon are Maria, vast plains of solidified lava that filled enormous impact basins billions of years ago. The word Maria is Latin for seas, because early astronomers thought these dark regions might be bodies of water, though we now know they are bone dry and have been for eons. What is strange about the Maria is their distribution. They are found almost exclusively on the near side of the Moon, the side that always faces Earth due to tidal locking, while the far side of the Moon, which remained unknown to humanity until the space age, is heavily cratered and almost entirely lacking in these dark lava plains. This asymmetry between the two hemispheres of the Moon is difficult to explain if the Moon formed naturally, because we would expect the distribution of impacts and volcanic activity to be more or less random across the entire surface. The near-side-far side dichotomy extends beyond just the presence or absence of Maria. The crust on the far side of the Moon is significantly thicker than the crust on the near side, sometimes by as much as 50 kilometers, and this difference in crustal thickness would have profound effects on the Moon's volcanic history and its response to impacts. Why should one side of the Moon be so different from the other? The conventional explanation involves complex interactions between Earth's gravity and the Moon's interior early in its history, creating conditions that favoured volcanism on the near side while suppressing it on the far side. But this explanation feels somewhat contrived, requiring a very specific set of circumstances to produce the observed asymmetry. If we entertain the possibility that the Moon is artificial, however, this asymmetry might make perfect sense as a design feature, with the near side intentionally constructed or modified to present a particular appearance to observers on Earth, while the far side served other purposes that did not require the same surface characteristics. The age of the Moon rocks returned by Apollo astronauts has also produced some surprising results. While most of the samples are indeed ancient, dating to around 4.5 billion years ago, consistent with the formation of the solar system, some of the rocks are even older than Earth itself, or at least older than the oldest rocks we have found on Earth's surface. This is not necessarily impossible in a natural scenario, because Earth's surface is constantly being recycled through plate tectonics, erosion, and volcanic activity, so the oldest rocks are continually being destroyed or buried, while the moon's surface is geologically dead and preserves ancient materials that would have long since vanished from Earth. Nevertheless, finding rocks on the moon that appear to predate the formation of Earth raises intriguing questions about where those materials came from and how they ended up incorporated into the moon's structure. Long before modern telescopes and space missions revealed the moon's secrets, ancient civilizations around the world looked up at the night sky and recorded observations that have come down to us through myths, legends, and fragmentary historical texts. Many of these ancient accounts contain references to the moon that seem strange or inexplicable when interpreted literally. And while mainstream scholars typically dismiss these stories as mythological fancy or poetic metaphor, it is worth considering whether some of them might preserve genuine historical memories of events or conditions that no longer exist. Scattered throughout the ancient world are references to a time before the moon, stories that explicitly state that the moon was not always present in Earth's sky. And while it is tempting to dismiss these as creation myths with no basis in reality, the fact that similar stories appear in cultures separated by vast distances and with no known contact with each other suggests that we should at least examine them more carefully. The ancient Greeks preserved stories of a people they called the Proselines, which literally means those who were before the moon. According to these accounts, the Arcadians, a people who lived in the mountainous interior of the Peloponnese Peninsula, claimed that their ancestors had inhabited the land since before there was a moon in the sky. The Greek writer Apollonius Rhodius, who lived in the 3rd century beside the Common Era, made reference to this tradition, and other Greek authors mentioned the Proselines in contexts that suggest this was a genuine belief held by the Arcadian people, and not merely a literary invention. The Greeks themselves did not necessarily believe that the moon had once been absent from the sky, but they faithfully recorded the claims of those who did, preserving for future generations a tradition that might otherwise have been lost. Similar traditions existed in other parts of the ancient world. In South America, indigenous peoples of the Andes Mountains told stories of a time in the distant past when the sky was different and the moon had not yet taken its place above the earth. Some of these legends speak of a great cataclysm, or a fundamental change in the order of the cosmos, after which the moon appeared and the world took on its current form. In Africa, certain oral traditions preserved by tribal historians speak of ancient times when the night sky was different, though the details have become fragmentary over the countless generations through which these stories have been passed. In Asia, ancient Hindu texts describe cycles of creation and destruction spanning vast periods of time. And embedded within these cosmic cycles are references to changes in the heavens that some interpreters have connected to the appearance or disappearance of celestial bodies. Scholars who study mythology in ancient cultures point out that these stories should not be taken as literal historical accounts, and this caution is certainly warranted because we know that myths serve many functions beyond simple record keeping, including explaining natural phenomena, establishing cultural identity, and encoding moral or spiritual teachings. However, the comparative study of mythology has also revealed that some myths do contain kernels of historical truth, memories of real events that have been embellished, distorted, or combined with legendary elements over time. Flood myths appear in cultures around the world, and while the details vary dramatically, most scholars now accept that many of these stories may preserve memories of real catastrophic floods that occurred at the end of the last ice age when rising sea levels inundated coastal areas and river valleys. If flood myths can preserve memories of events that happened 10 or 12,000 years ago, is it entirely impossible that other myths might preserve even older memories, perhaps memories passed down through countless generations from a time so remote that it existed before the current geological epoch? The problem with using mythology as evidence for actual historical events is the difficulty of separating fact from fiction. signal from noise. Myths are not carefully documented historical records. They are stories that have been told and retold, modified and adapted, merged with other stories and reinterpreted according to the needs and understanding of each successive generation. By the time a story has been transmitted orally for hundreds or thousands of years, the original events, if there were any, have been so thoroughly transformed that extracting reliable information becomes nearly impossible. And yet, the persistence of certain themes across widely separated cultures suggest that something meaningful might be embedded within these narratives, even if we cannot reconstruct the original events with any certainty. Beyond the myths that speak of a time before the moon, there are ancient texts that describe the moon in ways that seem to attribute to it properties or purposes beyond those of a simple natural satellite. In ancient Mesopotamia, the moon god Sin, also known as Nana, held a position of great importance in the religious pantheon, and the myths surrounding this deity sometimes describe the moon in terms that seem oddly technological or functional, rather than purely symbolic. The moon is described as measuring time, regulating the calendar, and maintaining cosmic order, which we might interpret as poetic ways of expressing the moon's role in marking the passage of months through its phases. But some of the language used in these texts has a curious precision to it, as though the ancient scribes were describing an actual mechanism or device rather than a divine being. The ancient Egyptians also held the moon in high regard, associating it with the god Thoth, who was credited with inventing writing, mathematics and science, and who was said to maintain the cosmic order through his wisdom and knowledge. Thoth was often depicted as a lunar deity, and the connection between the moon and measurement, calculation and record keeping appears repeatedly in Egyptian religious texts. The Egyptian calendar was based on both solar and lunar cycles, and the priests who maintained the calendar possessed sophisticated astronomical knowledge that allowed them to predict eclipses and other celestial events with impressive accuracy. Whether this knowledge was purely observational, or whether it incorporated theoretical understanding of the mechanisms underlying celestial motion, is difficult to determine from the surviving texts, but the level of precision achieved by ancient Egyptian astronomers suggests that they understood the moon's movements in considerable detail. In ancient China, detailed records of lunar observations stretch back thousands of years, and Chinese astronomers documented eclipses, the phases of the moon, and the positions of the moon relative to the stars with meticulous care. In ancient Mesopotamia, the moon god Sin, also known as Nana, held a position of great importance in the religious pantheon, and the myths surrounding this deity sometimes describe the moon in terms that seem oddly technological or functional rather than purely symbolic. The moon is described as measuring time, regulating the calendar and maintaining cosmic order, which we might interpret as poetic ways of expressing the moon's role in marking the passage of months through its phases. But some of the language used in these texts has a curious precision to it, as though the ancient scribes were describing an actual mechanism or device, rather than a divine being. The ancient Egyptians also held the moon in high regard, associating it with the god Thoth, who was credited with inventing writing, mathematics and science, and who was said to maintain the cosmic order through his wisdom and knowledge. Thoth was often depicted as a lunar deity, and the connection between the moon and measurement, calculation and record keeping appears repeatedly in Egyptian religious texts. The Egyptian calendar was based on both solar and lunar cycles, and the priests who maintained the calendar possessed sophisticated astronomical knowledge that allowed them to predict eclipses and other celestial events with impressive accuracy. Whether this knowledge was purely observational, or whether it incorporated theoretical understanding of the mechanisms underlying celestial motion, is difficult to determine from the surviving texts, but the level of precision achieved by ancient Egyptian astronomers suggests that they understood the moon's movements in considerable detail. In ancient China, detailed records of lunar observations stretch back thousands of years, and Chinese astronomers documented eclipses, the phases of the moon, and the positions of the moon relative to the stars with meticulous care. The Chinese viewed the moon as an essential component of the cosmic order, and any irregularities in its behavior were interpreted as omens that required careful interpretation. The extensive records maintained by Chinese astronomers have proven valuable to modern scientists studying long-term patterns in the Earth-Moon system, because they provide data points extending far beyond the reach of modern observational astronomy. When we examine these ancient records, we find that the moon's behavior has been remarkably consistent over the time period covered by human history, showing the same regular patterns and predictable cycles that we observe today, which is exactly what we would expect from a natural satellite governed by the laws of celestial mechanics. However, there are occasional anomalies in the ancient records, brief mentions of unusual phenomena or unexpected events involving the moon that do not quite fit into the pattern of normal lunar behavior. Some of these accounts describe the moon appearing larger or brighter than usual, which could be explained by atmospheric effects, or by the moon being at perigee, the point in its elliptical orbit when it is closest to Earth. Others describe the moon changing colour, turning red or dark, which is consistent with lunar eclipses and the way Earth's shadow affects the light reaching the moon's surface. But a few accounts are more difficult to explain, describing the moon behaving in ways that seem to violate the orderly patterns we have come to expect. These accounts are rare, and often lack the detail necessary to determine what was actually observed, making it impossible to draw firm conclusions, but they add to the accumulation of oddities and mysteries that surround our understanding of the moon. When Galileo Galilei turned his primitive telescope toward the moon in the early 17th century, he became one of the first human beings to see the lunar surface as something other than a smooth, perfect sphere. The revelation that the moon had mountains, valleys, and craters challenged the prevailing Aristotelian view that celestial bodies were perfect and unchanging, distinct from the flawed and mutable Earth. Galileo's observations marked the beginning of a new era in humanity's relationship with the moon, transforming it from an object of pure symbolism and mythology into a physical place that could be studied, measured, and understood through the methods of empirical science. As telescopes improved over the following centuries, astronomers mapped the moon's surface in increasing detail, naming the major features and attempting to understand the forces that had shaped the lunar landscape. The discovery that the moon was a world in its own right, with its own geography and geology, raised new questions about its origin and history. Early astronomers noticed that the moon always kept the same face toward Earth, never rotating to reveal its far side, and they correctly deduced that this was due to tidal locking, a phenomenon in which gravitational interactions between two bodies cause one to always present the same hemisphere to the other. The mathematics of orbital mechanics, developed by Isaac Newton and refined by later scientists, showed that tidal locking was a natural and inevitable consequence of gravitational forces acting over long periods of time, and this understanding removed one potential mystery from the moon's behavior. However, the very fact that the moon was tidally locked raised an interesting question. How long had this condition existed, and what was the moon's rotation rate in the distant past before tidal forces slowed it to its current state? As astronomical techniques became more sophisticated, scientists were able to measure the moon's distance from Earth with increasing precision, and in the 20th century they made a surprising discovery. The moon is slowly moving away from Earth at a rate of about 3.8 centimeters per year. This recession is a direct consequence of tidal interactions between Earth and the moon. The moon's gravity raises tidal bulges in Earth's oceans, and because Earth rotates faster than the moon orbits, these bulges are carried ahead of the point directly beneath the moon. The gravitational pull of these offset tidal bulges acts like a brake on Earth's rotation, gradually slowing it down, while simultaneously transferring angular momentum to the moon, causing it to spiral slowly outward. This process has been ongoing for billions of years, and it means that in the distant past, the Moon was much closer to Earth than it is today. Running this process backward in time, we can calculate that the Moon formed or arrived in orbit around Earth somewhere between 4 and 4.5 billion years ago, which is consistent with the age of the solar system and the geological evidence from both Earth and the Moon. This calculation provides strong support for the natural origin of the Moon, because it places the Moon's formation at the same time as the other major events in the early solar system, but it does not entirely eliminate the possibility of artificial intervention, because an advanced civilization with sufficient technology could potentially capture a body, place it in orbit, and set it on a trajectory that would mimic the natural evolution of an impact-generated satellite. The question becomes not whether such a feat is possible in principle, but whether there is any evidence that it actually occurred. In the mid-20th century, the space age began and humanity took its first tentative steps beyond Earth's atmosphere. The launch of artificial satellites, followed by crewed missions that eventually reached the Moon, transformed our understanding of the lunar environment in ways that ground-based observations could never achieve. The Apollo program, which placed 12 human beings on the lunar surface between 1969 and 1972, returned hundreds of kilograms of moon rocks and installed scientific instruments that continued to send data back to Earth for years after the astronauts departed. These missions provided the first direct evidence about the Moon's composition, structure, and history, confirming some theories, disproving others, and raising entirely new questions that scientists are still working to answer today. One of the most important discoveries from the Apollo program was the confirmation that the Moon is geologically dead and has been for billions of years. Unlike Earth, which is a dynamic planet with active volcanoes, shifting tectonic plates, and a magnetic field generated by a churning molten core, the Moon is cold, static, and inactive. The last volcanic eruptions on the Moon occurred more than 1 billion years ago, and there is no evidence of any ongoing geological processes beyond the slow accumulation of dust from micrometeorite impacts and the gradual erosion of surface features by solar radiation or the solar wind. This geological inactivity is consistent with the Moon being a small body that cooled quickly after its formation, losing its internal heat and becoming a frozen, unchanging world. However, the discovery of certain anomalies in the Moon's gravitational field suggested that all was not quite as simple as this picture implied. The Apollo missions included experiments in which the orbits of the command modules were carefully tracked as they circled the Moon, allowing scientists to create detailed maps of the Moon's gravitational field. These maps revealed the presence of mass concentrations or mascons beneath the lunar surface, regions where the density of material is significantly higher than in the surrounding areas. The mascons are located primarily beneath the large impact basins on the near side of the Moon, and they are thought to be the remnants of the impactors that created those basins, dense metallic cores of asteroids or comets that punched through the lunar crust and became embedded in the subsurface. The presence of these mascons causes spacecraft orbits to be slightly perturbed, and understanding their distribution was essential for planning the Apollo landings and for the operation of later lunar missions. However, the mascons also raise questions about the Moon's internal structure and thermal history. If the Moon had remained geologically active for a significant period after the formation of these impact basins, the dense material should have gradually sunk deeper into the interior due to gravity, much like heavy objects sink in a fluid. The fact that the mascons are still present as discrete concentrations suggests that the Moon's interior solidified very quickly, freezing the dense material in place before it could redistribute itself. This rapid cooling is consistent with the small size of the Moon, but it also means that the Moon's interior must be quite rigid and strong, capable of supporting the mass concentrations without deforming over billions of years. Some researchers have noted that this rigidity is greater than what we would expect from a body composed entirely of ordinary rock. and they have proposed that the moon's interior might contain materials or structures that enhance its strength, though what those materials might be remains speculative. Among the many unusual characteristics of the moon, perhaps none has captured the imagination of alternative researchers quite like the seismic data that some interpret as evidence that the moon might be partially hollow. This idea, often called the hollow moon hypothesis, emerges from observations made during the Apollo missions, when seismometers placed on the lunar surface recorded the moon's response to impacts and moonquakes. The duration and character of the seismic vibrations were unexpected, and while mainstream scientists have proposed explanations that keep the moon within the bounds of natural formation, a minority of researchers have suggested that the data is more consistent with the moon having large void spaces or cavities within its interior, possibly indicative of artificial construction. The most famous incident that sparked the hollow moon speculation occurred during the Apollo 12 mission in November of 1969. After the astronauts had returned to lunar orbit and were preparing to leave the moon, they jettisoned the lunar module ascent stage, which crashed back onto the lunar surface with a force equivalent to detonating about a ton of TNT. The seismometers that had been deployed during the mission recorded the impact, and to the surprise of the scientists monitoring the data, the moon rang like a bell, with vibrations continuing for more than an hour. The signal gradually diminished over time, but it persisted much longer than would be expected from an impact of that size on a solid rocky body. Similar results were observed during later Apollo missions when spent rocket stages and lunar modules were deliberately crashed into the moon, sometimes producing reverberations that lasted for several hours. The conventional explanation for this prolonged ringing is that the moon's interior is highly fractured and contains many cracks and fissures that scatter seismic waves, causing them to bounce around within the lunar crust for an extended period before finally dissipating. On Earth, seismic waves from earthquakes are damped relatively quickly because our planet's interior contains water, which absorbs vibrational energy, and because Earth's crust is layered and heterogeneous, providing many interfaces where seismic waves can be reflected or absorbed. The moon, by contrast, is bone dry, lacking any water in its interior, and its upper layers may be composed of relatively uniform material that allows seismic waves to propagate efficiently without much energy loss. According to this model, the moon's prolonged ringing is unusual but not impossible to explain within the framework of natural planetary formation. However, some researchers have pointed out that the seismic data could also be consistent with the moon having a different internal structure than is typically assumed, possibly including large hollow spaces or cavities. If the moon's interior contains voids, seismic waves would reflect off the boundaries between solid material and empty space, creating complex patterns of interference and resonance that could explain the observed duration of the vibrations. A hollow or partially hollow moon would act somewhat like a bell or a drum, with the solid outer shell vibrating in response to impacts, while the empty interior provides a space for those vibrations to reverberate. This interpretation is controversial and is not accepted by the majority of lunar scientists, who argue that there is no independent evidence for hollow spaces and that the conventional explanation of a dry, fractured interior is sufficient to account for the observations. If we entertain the possibility that the moon is indeed hollow or partially hollow, we must immediately confront the question of how such a structure could have formed. Natural processes do not typically create hollow planetary bodies because gravity tends to compress matter inward, creating solid or layered structures with the densest material concentrated at the center. The only natural way to produce significant void spaces would be through volcanic activity, which can create lava tubes and caves, but these features are typically small compared to the size of the planetary body, and are found only in the outer crust, not deep in the interior. To create a moon with a large internal cavity would require a mechanism entirely outside the range of known natural processes, which leads directly to the conclusion that if the moon is hollow, it must be artificial. The concept of an artificial moon raises profound questions about who might have built it, when, and for what purpose. If the moon is a constructed object, it represents a level of engineering capability far beyond anything humanity has achieved or even seriously contemplated. The moon has a mass of approximately 7.3 times 10 to the 22nd kilograms, a scale of construction that dwarfs any human project by many orders of magnitude. Building such an object would require not only the ability to manipulate enormous quantities of material, but also the knowledge and technology to place that object in a stable orbit around a planet, and to give it the appearance of a natural satellite. The civilization capable of such a feat would need to be ancient beyond measure, because the evidence suggests that the moon has been in orbit around Earth for billions of years, long before life even began on our planet, let alone before intelligent life evolved. Proponents of the artificial moon hypothesis often point to the numerous anomalies and coincidences associated with the moon as cumulative evidence that something unusual is going on. They argue that while each individual oddity might be explainable as a natural phenomenon or a statistical coincidence, the collection of anomalies as a whole paints a picture that is more consistent with design than with random chance. The perfect size match during solar eclipses, the unusual proportional size of the moon relative to Earth, the distribution of Maria on the near side only, the seismic characteristics, the gravitational anomalies, and the peculiarities of the moon's composition and orbit all combine to create a pattern that, according to this view, suggests intentional construction rather than natural formation. Critics of the artificial moon hypothesis counter that this reasoning falls into the trap of cherry-picking data and ignoring the vast amount of evidence that supports natural formation. They point out that the giant impact hypothesis, while not perfect, successfully explains most of the moon's major characteristics and is supported by computer simulations, chemical analysis of lunar samples, and our understanding of planetary formation processes in the early solar system. The anomalies that remain can be attributed to our incomplete understanding of complex systems and the difficulty of reconstructing events that occurred billions of years ago from limited evidence. Extraordinary claims require extraordinary evidence, and the case for an artificial moon, according to skeptics, simply does not meet this standard. The idea that the moon might be artificial fits naturally into a broader framework of speculation about ancient advanced civilizations and extraterrestrial visitors, a framework that has been popularized in books, television shows, and internet discussions over the past several decades. According to these theories, Earth has been visited repeatedly throughout its history by intelligent beings from other worlds, and these visitors have left behind traces of their presence in the form of mysterious artifacts, unexplained ancient structures, and anomalous objects like the moon itself. While mainstream science regards these ideas with skepticism or outright dismissal, the popularity of ancient astronaut theories reflects a deep human fascination with the possibility that we are not alone in the universe and that our history might be far more complex and mysterious than we have been taught. The ancient astronaut hypothesis suggests that many of the puzzling aspects of ancient cultures, from the construction of massive stone monuments to the sudden appearance of advanced knowledge in mathematics and astronomy, can be explained by contact with extraterrestrial civilizations. Proponents point to ancient texts that describe gods descending from the sky in fiery chariots, to artifacts that seem technologically advanced for their time period, and to architectural achievements that appear to require engineering knowledge beyond what we believe ancient peoples possessed. The Great Pyramid of Giza, the stone heads of Easter Island, the Nazca Lines in Peru, and countless other archaeological mysteries are cited as evidence that someone with advanced technology was active on Earth in the distant past, either directly building these structures or teaching ancient humans how to build them. If we accept, even hypothetically, that advanced extraterrestrial visitors have been active in Earth's vicinity, then the moon becomes a logical focal point for their activities. The moon occupies a unique position in the Earth-Moon system, close enough to Earth to observe and influence events on the planet's surface, but far enough away to remain separate and protected from Earth's environment and potential threats. An artificial moon could serve multiple functions simultaneously: as an observation post for monitoring the development of life on Earth, as a base of operations for a civilization conducting long-term experiments or projects in this solar system, as a marker or beacon indicating the presence of an inhabited planet, or even as a massive spacecraft or ark that brought its builders to the solar system from some distant star. The engineering required to construct a moon-sized artificial object is staggering, but it is not necessarily impossible from a theoretical standpoint. Modern physicists and engineers have sketched out concepts for megastructures that can be built by sufficiently advanced civilizations, given enough time, resources, and energy. The Dyson sphere, a hypothetical structure that completely encloses a star to capture all of its energy output, is perhaps the most famous example of this kind of thinking, but others have proposed rotating habitats, artificial planets, and other large-scale constructions that would be visible across interstellar distances. The Moon, if artificial, would represent a megastructure of a different sort, one designed not to maximize surface area or energy collection, but to mimic a natural satellite while serving hidden purposes known only to its creators. One of the key questions that arises in any discussion of an artificial moon is the question of age. The geological evidence strongly suggests that the moon has been in its current position for approximately 4.5 billion years, since the earliest days of the solar system. If the moon is artificial, this means it was constructed or placed in orbit around Earth during the solar system's youth, long before life appeared on Earth and billions of years before the evolution of human beings. Why would anyone go to the trouble of building an artificial moon and placing it around a lifeless, molten planet that would not develop intelligent life for eons? The timescales involved are so vast that they challenge our normal intuitions about purpose and intention. What kind of civilization thinks in terms of billions of years, and what goals could possibly justify such patience? One possible answer is that the builders of the moon were not primarily interested in Earth as it existed 4.5 billion years ago, but rather in what Earth would become. If an advanced civilization possessed the ability to predict planetary evolution and the emergence of life, they might have identified Earth as a world that would eventually develop complex biospheres and possibly intelligent species. By placing an artificial moon in orbit early in Earth's history, they could influence the planet's development in subtle but important ways, while simultaneously creating a permanent observation post that would be present throughout the entire history of life on Earth. The moon's gravitational influence on Earth has had profound effects on our planet's evolution, stabilizing the tilt of Earth's rotational axis, creating tides that may have played a role in the development of life, and possibly affecting Earth's climate in ways that made the emergence of complex life more likely. The stabilization of Earth's axial tilt is particularly interesting from this perspective. Earth's axis is currently tilted at about 23.5 degrees relative to the plane of its orbit around the Sun, and this tilt is responsible for our seasons and for the distribution of solar energy across different latitudes. Computer simulations have shown that without the moon's gravitational influence, Earth's axial tilt would vary chaotically over time, sometimes wobbling to extreme angles that would cause dramatic climate shifts and possibly make the development of complex life much more difficult. Mars, which lacks a large moon, experiences exactly this kind of chaotic variation in its axial tilt, and this instability may be one reason why Mars has remained relatively lifeless despite once having liquid water on its surface. Earth, by contrast, has enjoyed a stable axial tilt for billions of years, creating a relatively predictable climate that has allowed life to evolve and diversify. If the moon was intentionally placed in orbit to stabilize Earth's axis, this would represent a form of planetary engineering or terraforming on a scale almost beyond comprehension. The builders would have needed not only the ability to construct or move a moon-sized object, but also the foresight to understand that such stabilization would be beneficial for the development of life, and the patience to wait billions of years for that life to emerge. This kind of long-term thinking is alien to human nature, accustomed as we are to planning on scales of years or at most decades, but it might be natural to a civilization that had already achieved a level of technological and social development that made them essentially immortal, or at least capable of maintaining continuity over geological timescales. Another angle from which to approach the mystery of the moon's origin involves considering not just Earth and the moon in isolation, but the solar system as a whole and the broader context of planetary formation. When we survey the architecture of the solar system, we find patterns and regularities that suggest common formation processes, but we also find gaps and irregularities that hint at a more chaotic and violent history than the orderly arrangement of planets might initially suggest. One of these irregularities is the relatively small size of Mars and the absence of any planet in the asteroid belt, a region between Mars and Jupiter where planetary formation models suggest a planet should have formed but apparently did not. Some researchers have proposed that there once was another planet in the early solar system, sometimes referred to as Planet V, or by other hypothetical names, that existed for a time but was destroyed or ejected from the solar system through gravitational interactions with the other planets. The asteroid belt might be the remnants of this lost planet, shattered by a collision or torn apart by Jupiter's gravity, though most astronomers think the asteroid belt represents material that never coalesced into a planet in the first place, prevented from doing so by Jupiter's gravitational influence. Nevertheless, the idea of a missing planet raises intriguing possibilities, because if such a planet existed and was destroyed, where did its moons go? Planets have moons, and a planet in the asteroid belt region would likely have had one or more satellites orbiting it. If that planet was destroyed in a catastrophic collision, its moons would have been thrown into chaotic orbits, potentially wandering the inner solar system until they were captured by another planet, crashed into the sun, or were ejected into interstellar space. Could the moon be such a wanderer, a refugee from a destroyed world that was eventually captured by Earth's gravity? This scenario is speculative and faces many of the same difficulties as other capture scenarios, namely the problem of explaining how Earth could have captured such a large object into such a circular and well-behaved orbit. But it provides a narrative framework in which the moon's unusual properties might make more sense as the result of a complex and violent history rather than a single formation event. The notion of planetary instability and migration in the early solar system has gained support from computer simulations that model the gravitational interactions between the young planets. These simulations suggest that the current configuration of the solar system is not necessarily the same as the original arrangement when the planets first formed. The gas giants in particular may have migrated significantly, moving inward or outward from their initial positions as they exchanged angular momentum with the swarms of smaller bodies that filled the early solar system. The NICE model, named after the French city where much of this work was done, proposes that Jupiter, Saturn, Uranus and Neptune all underwent significant orbital migration, and that this migration triggered a period of intense bombardment in the inner solar system, sending a shower of comets and asteroids inward to collide with the terrestrial planets. This period of heavy bombardment is recorded in the cratered surfaces of the Moon, Mercury and Mars, and it is thought to have occurred roughly 4 billion years ago, a few 100 million years after the formation of the solar system. The exact triggers and timing of this bombardment period are still debated, but if the NICE model is correct, it means that the early solar system was a far more dynamic and dangerous place than previously believed, with planets moving, collisions occurring, and smaller bodies being scattered throughout the system. In such a chaotic environment, unusual events like the capture of a large moon or the arrival of an artificial object would be more plausible, because the background level of orbital instability and gravitational perturbations would have been much higher than in the current, more settled solar system. If we continue to pursue the idea that the moon might be artificial and might have arrived from elsewhere, we must consider what kind of trajectory it might have followed and how it could have been placed into orbit around Earth. An object travelling through the solar system from the outer regions or from another star system would typically be on a hyperbolic orbit, meaning it would pass through the inner solar system once and then escape back into interstellar space unless something slowed it down. To capture such an object into a circular orbit around Earth would require precisely timed maneuvers that reduced its velocity at just the right moment, essentially requiring active propulsion or some other form of energy expenditure. Natural capture is possible if the incoming object encounters a planet at just the right angle and speed, and if additional factors like atmospheric drag or gravitational assists from other bodies help dissipate energy. But for an object as large as the Moon, the required conditions are extremely specific and unlikely. If the Moon arrived under intelligent control, however, the capture problem becomes much simpler. A spacecraft or mobile artificial object could use propulsion to adjust its orbit, matching velocities with Earth and gradually settling into a stable circular path. The energy requirements would be enormous, roughly equivalent to the total energy output of the Sun for several hours, but for a civilization capable of building a moon-sized object in the first place, such energy expenditures might be feasible. Advanced propulsion technologies that we can barely imagine, such as matter-antimatter engines, controlled fusion, or even manipulation of space-time itself, could provide the necessary thrust, and the long time scales available for the maneuver would allow the object to spiral gradually into its final orbit, rather than needing to decelerate instantaneously. Throughout recorded history, observers have occasionally reported seeing unusual lights, glows, or other strange phenomena on the Moon's surface, occurrences that have come to be known collectively as transient lunar phenomena, or TLPs. These reports date back centuries and come from both professional astronomers and amateur observers, describing brief flashes of light, localized changes in brightness, coloured patches that appear and disappear, or misty obscurations that temporarily blur surface features. The scientific status of these observations is ambiguous because most TLPs are brief and unpredictable, making them difficult to verify or study systematically, and because many can be explained as optical effects caused by Earth's atmosphere, equipment artifacts, or observation errors. Nevertheless, some TLPs have been witnessed by multiple independent observers or have been photographed, lending them a degree of credibility that cannot be easily dismissed. The crater Aristarchus, located on the near side of the Moon, is a particular hotspot for TLP reports, with dozens of documented observations of unusual glowing or coloured patches in that region. Other areas that have generated repeated reports include the crater Plato, the Alpine Valley, and various locations within the Morea. Some researchers have attempted to catalogue and analyse these reports systematically, looking for patterns in their timing, location, or characteristics, but the data remains frustratingly inconsistent, with no clear pattern emerging that would point to a single underlying cause. The conventional explanations for TLPs typically invoke outgassing, the release of trapped gases from the lunar interior, which might create temporary clouds of material above the surface that could scatter sunlight in unusual ways. The Moon is generally considered to be geologically dead, with no ongoing volcanic activity, but it is possible that pockets of gas remain trapped in subsurface voids and are occasionally released when solar heating or tidal stresses create cracks or fractures. Another explanation involves electrostatic charging of the lunar surface by the solar wind, which could cause dust particles to levitate temporarily, creating a kind of dust fountain that might appear as a glow or obscuration when viewed from Earth. Meteorite impacts also occur regularly on the Moon, and larger impacts could create bright flashes visible from Earth, though these would be rare and extremely brief. The problem with these natural explanations is that they struggle to account for the full range of reported phenomena, particularly the observations that describe structured or localized glows that persist for minutes or hours, move across the surface, or change in color or intensity. Such behavior is difficult to reconcile with the random diffuse processes like outgassing or electrostatic effects, and it has led some researchers to speculate that at least some TLPs might represent something more unusual, perhaps even evidence of artificial activity on the lunar surface. This speculation remains highly controversial and is not taken seriously by most lunar scientists, who argue that the evidence for artificial activity is weak and that unexplained observations do not automatically imply artificial causes. If the moon were indeed an artificial structure, or if it harbored some kind of ancient installation or machinery, we might expect to see occasional signs of activity, especially if whatever systems were put in place billions of years ago were still functioning or periodically activating. Science fiction has explored this possibility extensively, with stories about dormant alien bases on the moon awakening when certain conditions are met, or about ancient monitoring equipment continuing to operate long after its creators have vanished. While such scenarios remain firmly in the realm of fiction without concrete evidence, they provide a narrative framework for thinking about what we might observe if the moon were more than just a dead rock. The Apollo missions themselves have generated their own collection of unexplained observations and strange incidents that have been seized upon by those who believe the moon harbors mysteries beyond the official scientific narrative. Astronauts have reported seeing flashes of light inside their spacecraft and on the lunar surface, which have been attributed to cosmic rays striking their eyes or equipment, but some descriptions do not quite fit this explanation. Radio communications between the astronauts and mission control were occasionally interrupted or contained odd sounds and interference that could not be immediately explained, though most of these incidents were later attributed to equipment malfunctions or electromagnetic interference from various sources. Photography from the lunar surface and from orbit has revealed occasional features or patterns that some interpret as evidence of artificial structures, though the overwhelming majority of these turn out to be natural rock formations, shadows, or artifacts of the photographic process. One of the most persistent lunar mysteries involves the reports by Apollo astronauts of seeing unusual objects or lights during their missions. While these accounts are often exaggerated or distorted in popular retellings, there are documented instances where astronauts described seeing things they could not immediately identify, only to have those observations later explained as pieces of the spacecraft, reflections, or other mundane phenomena. The human brain is wired to recognize patterns, especially faces and structured objects, and in the stark, unfamiliar environment of the moon, it is not surprising that astronauts occasionally misinterpreted what they were seeing. However, the fact that some observations were never fully explained has kept speculation alive that the astronauts might have witnessed something genuinely anomalous. Setting aside the question of whether the moon is natural or artificial, there is no dispute that the moon has had a profound influence on Earth and on the development of life on our planet. The most obvious effect is the tides, the daily rise and fall of sea level caused by the moon's gravitational pull on Earth's oceans. Tides are not merely an inconvenience for sailors or a source of predictable coastal flooding. They play a crucial role in the ecology of coastal environments, creating intertidal zones where organisms must adapt to regularly alternating conditions of submersion and exposure to air. Many scientists believe that these intertidal zones may have been important in the evolution of life, providing a kind of transitional environment where early organisms could adapt to both aquatic and terrestrial conditions, eventually leading to the colonization of land by plants and animals. The moon's influence on tides also has geophysical consequences. The friction caused by tidal movement gradually dissipates energy, which has two effects. It slows Earth's rotation, gradually lengthening the day, and it causes the moon to slowly recede from Earth as angular momentum is transferred from Earth's rotation to the moon's orbit. This process has been ongoing for billions of years, and it means that in the deep past, Earth rotated faster and the day was shorter, while the moon was closer and appeared larger in the sky. There is evidence from ancient tidal rhythmites, layered sedimentary rocks formed in tidal environments, that support this picture, showing that the length of the day has indeed increased over geological time exactly as the theory predicts. The moon's stabilization of Earth's axial tilt has already been mentioned, but it is worth emphasizing just how important this stabilization has been for Earth's climate and the development of complex life. A stable axial tilt means predictable seasons and a relatively constant distribution of solar energy across different latitudes, creating climate zones that remain broadly similar over long periods of time. This predictability allows ecosystems to adapt and specialize, leading to greater biodiversity and ecological complexity. Without the moon, Earth's axis might tumble chaotically, causing the poles to sometimes point almost directly at the sun and at other times to lie nearly in the plane of Earth's orbit. Such variations would create extreme climate swings, with ice ages and hothouse conditions alternating on timescales far too rapid for most species to adapt, likely resulting in frequent mass extinctions and a much more impoverished biosphere. The moon has also served as a shield of sorts, absorbing impacts from asteroids and comets that might otherwise have struck Earth. The heavily cratered surface of the moon testifies to the intense bombardment that the Earth-Moon system has endured over billions of years, and while Earth has certainly suffered its share of impacts, the moon's presence has reduced the frequency of these catastrophic events. Some of the impacts that struck the moon would have struck Earth instead if the moon had not been there, potentially altering the course of evolution or even preventing the development of complex life. This protective role is not absolute, because the moon's gravitational influence also perturbs the orbits of some objects in ways that can send them toward Earth, but on balance, the moon likely provides a net benefit in terms of reducing the impact hazard. Beyond these physical effects, the moon has had an immeasurable influence on human culture, psychology, and development. The lunar cycle has provided humanity with its first natural calendar, allowing ancient peoples to track the passage of time and to plan agricultural activities according to the seasons. The moon's phases are so regular and predictable that they served as the basis for the earliest systematic attempts to understand celestial mechanics and to develop mathematical descriptions of astronomical phenomena. The ability to predict the moon's phases and position was a form of power in ancient societies, and the astronomer priests who possessed this knowledge often occupied positions of great authority and respect. The moon has also served as a source of inspiration and wonder, fueling myths, legends, poetry, and art across every human culture. The pale light of the full moon has been associated with madness, transformation, and magic, while the new moon has been seen as a time of darkness and renewal. The moon appears in the creation stories of countless cultures, sometimes as a deity in its own right, sometimes as the home of gods or spirits, and sometimes as a symbol of the feminine, the cyclical, and the mysterious. Without the moon, human culture would be profoundly different, lacking one of its most potent and universal symbols, and it is difficult to imagine how our species might have developed if the night sky had been moonless. If the moon were indeed an artificial object placed in orbit by an advanced civilization, the influence it has had on Earth takes on an additional layer of meaning. Rather than being accidental side effects of a naturally formed satellite, the stabilization of Earth's axis, the creation of tides, and the provision of a celestial timekeeper would all be intentional design features carefully calculated to nurture the development of life and intelligence on the planet below. This interpretation transforms the moon from a passive object into an active participant in Earth's history, a silent guardian that has been watching over our world for billions of years, shaping its evolution in subtle but crucial ways, and waiting patiently for the moment when the planet's inhabitants would develop the technology and curiosity to finally recognize what the moon truly is. When humanity finally developed the technology to leave Earth and explore space directly, one of the first and most important targets was the moon. The race to reach the moon became a focal point of Cold War competition between the United States and the Soviet Union, driving rapid advances in rocket technology, spacecraft design, and computer systems. Both nations viewed the moon not just as a scientific prize, but as a symbol of technological and ideological superiority, and the successful landing of Apollo 11 astronauts Neil Armstrong and Buzz Aldrin on the lunar surface in July of 1969 represented a triumph of human ingenuity and determination. The images of astronauts walking on the moon, bouncing across the dusty surface in the low gravity, and planting the American flag became iconic symbols of the space age and remain some of the most recognizable photographs in human history. The Apollo program consisted of 6 successful lunar landings between 1969 and 1972, with each mission exploring different regions of the moon and conducting increasingly sophisticated scientific experiments. The astronauts deployed seismometers to measure moonquakes, collected hundreds of kilograms of rock samples, photographed the surface in detail, and left behind retroreflectors that allowed scientists on Earth to measure the distance to the moon with extraordinary precision by bouncing laser beams off them. The wealth of data returned by Apollo transformed our understanding of the moon, confirming that it was indeed a geologically dead world covered in ancient impact craters and billions of years old, but also revealing unexpected details and anomalies that did not quite fit the prevailing theories of lunar formation. One surprising discovery was the presence of water ice in permanently shadowed craters near the lunar poles. For decades after the Apollo missions, scientists believed that the moon was completely dry, lacking any water or volatile compounds anywhere on or beneath its surface. The lunar samples returned by Apollo contained virtually no water, and the high temperatures reached by rocks exposed to direct sunlight during the lunar day would cause any water to quickly evaporate and escape into space. However, in permanently shadowed craters near the poles, where sunlight never reaches, temperatures remain cold enough to preserve ice for billions of years. Observations from later missions, including orbiters and impactors deliberately crashed into these shadowed regions, confirmed the presence of significant quantities of water, ice, opening up the possibility that the moon might harbour resources that could be used to support future human exploration, or even permanent lunar bases. The discovery of water on the moon raises questions about where that water came from. The most likely source is comets and water-rich asteroids that have struck the moon over billions of years, depositing small amounts of water with each impact. In most areas of the moon, this water would be lost almost immediately, but in the cold traps of the polar craters, it can accumulate over geological time. However, some researchers have noted that the quantity and distribution of lunar water is difficult to explain entirely through comet impacts, and they have speculated about other possible sources, including the possibility that some water is primordial, incorporated into the moon during its formation, or even the water might be continuously generated on the lunar surface through interactions between the solar wind and oxygen-bearing minerals. These alternative explanations remain speculative and are not widely accepted, but they illustrate the point that even seemingly simple questions about the moon can have complex and uncertain answers. Soviet Union, although it lost the race to land humans on the moon, conducted its own lunar exploration program using robotic spacecraft. Soviet landers and rovers successfully operated on the lunar surface, and robotic sample return missions brought lunar soil back to Earth without the need for human astronauts. These missions demonstrated that much of the scientific work of exploring the moon could be done using automated systems, a lesson that has influenced the design of subsequent planetary missions. The Soviet lunar program also involved ambitious plans for permanent lunar bases, and even proposals to use nuclear explosives to excavate large craters for construction purposes, though these plans were never carried out due to technical challenges and changing political priorities. After the end of the Apollo program in 1972, human interest in the moon waned considerably, The enormous expense of the Apollo missions, combined with the lack of obvious economic or strategic benefits from continued lunar exploration, led both the United States and the Soviet Union to shift their focus to other areas of space exploration, including Earth-orbiting space stations, robotic missions to other planets, and the development of reusable spacecraft like the Space Shuttle. For more than 3 decades, no nation sent missions to the Moon, and it seemed as though humanity's brief love affair with our nearest celestial neighbour had ended. However, beginning in the 1990s and accelerating in the 21st century, interest in the Moon has resurged, driven by a combination of scientific curiosity, technological advances, and the emergence of new spacefaring nations eager to demonstrate their capabilities. China's lunar program has been particularly ambitious and successful, with a series of orbiters, landers, and rovers exploring the Moon and returning high-quality data and images. In 2019, China became the first nation to successfully land a spacecraft on the far side of the Moon, a technically challenging feat because direct radio communication with Earth is impossible from the far side, requiring a relay satellite to be positioned at a special location where it can see both the far side of the Moon and Earth simultaneously. India, Japan, and several other nations have also launched lunar missions. Private companies have announced plans to send commercial spacecraft to the Moon for purposes ranging from scientific research to resource extraction. This new wave of lunar exploration promises to greatly expand our knowledge of the Moon and may finally provide answers to some of the long-standing mysteries about its origin and nature. To seriously evaluate the possibility that the Moon might be artificial, it is instructive to consider what such a project would entail from an engineering standpoint. Building or significantly modifying a moon-sized object represents an undertaking on a scale that challenges our intuitions about what is possible, even in principle. The Moon's mass, as mentioned earlier, is about 7.3 times 10 to the 22nd kilograms, and its mean radius is roughly 1,737 kilometers. These are not numbers that human brains are well equipped to grasp intuitively, so perhaps it is helpful to approach the problem by comparison and by breaking it down into more manageable components. Let us imagine that an advanced civilization wanted to construct an artificial moon from raw materials. Where would they obtain those materials, and how would they process them? The asteroid belt contains vast quantities of rock and metal, far more than enough to build many moons, and it has the advantage of being relatively accessible in terms of gravitational energy because the asteroids are small bodies with very low escape velocities. Mining asteroids would be comparatively easy compared to mining a planet's surface, and the lack of atmospheric or environmental concerns would simplify operations. Once materials were extracted from asteroids, they would need to be transported to the construction site and assembled into the desired structure. For an object as large as the Moon, this would require an enormous fleet of spacecraft and a construction timeline that might span thousands or even millions of years, depending on the pace of work and the resources available. Alternatively, the builders might have started with an existing planetary body and modified it to suit their purposes. This approach would have the advantage of not requiring the transportation of vast quantities of material across interplanetary distances, but it would present its own challenges in terms of excavating, reshaping, or hollowing out the interior of a massive object while maintaining its structural integrity. If the goal was to create a hollow moon, the builders would need to remove material from the interior and transport it elsewhere, or perhaps use it to construct the outer shell, creating a structure somewhat like a Russian nesting doll with a solid shell surrounding a hollow cavity. The engineering required to ensure that such a structure could support its own weight under gravity without collapsing would be formidable, requiring either incredibly strong materials or some kind of internal support framework. The energy requirements for such a project are staggering. Simply lifting the Moon's mass out of the gravitational well of the Sun and into orbit around Earth would require energy equivalent to the Sun's total output for an extended period, and this does not account for the additional energy needed for mining, processing, construction, and all the other activities involved in the project. A civilization undertaking such a task would need access to energy sources far beyond anything humanity currently possesses, and they would need to be able to harness and direct that energy with extraordinary precision and efficiency. Possible energy sources might include the complete conversion of matter into energy through matter-antimatter reactions, the harnessing of the energy output of stars through structures like Dyson spheres, or perhaps technologies that we have not yet imagined, such as tapping into the zero-point energy of the vacuum, or manipulating higher dimensional structures. Time is another critical factor. Even with unlimited energy and resources, the construction of a moon-sized object would take a very long time, simply due to the scale of the project and the number of individual operations that would need to be performed. If we assume that the builders could process and position material at a rate of, say, 1 million tons per second, which is an absurdly fast rate that far exceeds anything humans have achieved, it would still take more than 2,000 years to assemble the entire mass of the moon. More realistic construction rates would extend the timeline to tens or hundreds of thousands of years, and if the project involved complex internal structures or required precision in assembly, the timeline could stretch into millions of years. A civilization embarking on such a project would need to be extraordinarily patient and stable, maintaining continuity of purpose across timescales that dwarf the entire span of recorded human history. Despite these enormous challenges, there is nothing in the laws of physics that forbids the construction of a moon-sized artificial object. It is a matter of engineering, not of fundamental physical impossibility, and this is an important distinction. Many things that seem impossible to us are merely impractical or beyond our current technological reach, not violations of the basic principles that govern the universe. A sufficiently advanced civilization, one that had mastered the manipulation of matter and energy at scales far beyond our current abilities, could in principle undertake projects that seem godlike to us. The question is not whether such feats are possible in some abstract sense, but whether there is any evidence that such a civilization existed and chose to create or modify the moon. Some proponents of the artificial moon hypothesis argue that the evidence is hiding in plain sight, that the moon's very existence and its unusual properties are themselves the evidence, and that we fail to recognize this only because we are too committed to the assumption that everything we see must have a natural origin. They point out that if we encountered an object in space that had all the characteristics of the moon but had never been to Earth, we might be more willing to entertain the possibility that it was artificial. But because the moon has always been part of our experience and part of our scientific thinking, we have a psychological blind spot that prevents us from seeing it for what it might really be. This argument has some merit as a critique of scientific assumptions, but it does not constitute proof, and the burden of evidence still rests on those claiming that the moon is artificial to provide positive evidence beyond the catalogue of anomalies and coincidences. One way to assess whether the moon's properties are genuinely unusual or merely reflect our ignorance of natural processes is to compare the Earth-Moon system to other planetary systems, both within our solar system and around other stars. The field of comparative planetology examines the similarities and differences between planets and moons throughout the universe, looking for patterns that can reveal underlying physical processes and formation mechanisms. As our observational techniques have improved, we have discovered thousands of planets orbiting other stars, and while we cannot yet detect moons around these exoplanets with current technology, we can at least study the diversity of planetary systems and consider whether systems like ours are common or rare. Within our own solar system, the diversity of moons is remarkable. Jupiter and Saturn each have dozens of moons, ranging from tiny irregular captured asteroids to large regular satellites like Ganymede, Callisto, Io, Europa, Titan, and Enceladus. Some of these moons are geologically active, with volcanism on Io driven by tidal heating, and possible subsurface oceans on Europa and Enceladus that might harbour life. Uranus and Neptune also have substantial moon systems, including Triton, Neptune's largest moon, which orbits in a retrograde direction, suggesting that it was captured rather than forming in place. The terrestrial planets, by contrast, have far fewer moons. Mercury and Venus have none at all. Mars has 2 tiny captured asteroids, and Earth has the Moon. This distribution suggests that the formation of large moons around terrestrial planets is uncommon, and the Earth-Moon system stands out as an exception rather than the rule. The moons of the gas giants provide important clues about moon formation processes. Most large moons in the outer solar system formed in circumplanetary disks, rotating clouds of gas and dust that surrounded the newly formed planets during the final stages of their assembly. These moons grew by accretion, the gradual accumulation of smaller particles into larger bodies, in much the same way that planets form from the circumstellar disk around a young star. The regular moons of Jupiter and Saturn, those with nearly circular orbits lying in the plane of their planet's equator, are thought to have formed this way, while irregular moons with eccentric or retrograde orbits are believed to be captured objects. The Earth-Moon system does not fit neatly into either category, because the Moon is too large to have formed from a circumplanetary disk, yet its orbit is too regular and well-behaved to suggest a straightforward capture event. The giant impact hypothesis remains the leading explanation for the Moon's origin precisely because it can account for this intermediate position. A collision between the proto-Earth and a Mars-sized impactor would have created a massive debris disk around Earth, and the Moon could have formed from this debris through accretion over a relatively short period, perhaps only a few thousand years. This scenario combines elements of both disk formation and catastrophic event, explaining the Moon's size and composition while accounting for its regular orbit. However, as we have discussed, the details of this scenario are not without problems, and alternative models continue to be explored by researchers seeking to resolve the remaining inconsistencies. The search for exoplanets has revealed that planetary systems come in a bewildering variety of configurations, many of which are quite different from our solar system. We have discovered hot Jupiters, gas giant planets orbiting very close to their stars, super-Earths, rocky planets larger than Earth but smaller than Neptune, planets orbiting binary star systems, and systems where planets are packed much more tightly together than in our solar system. This diversity suggests that planetary formation is a complex and highly variable process that can produce many different outcomes depending on the initial conditions and the specific sequence of events during the system's formation. In this context, the unusual nature of the Earth-Moon system might simply reflect the fact that planetary systems are diverse and that many different configurations can arise naturally without requiring artificial intervention. However, the very diversity of planetary systems also raises interesting questions about our place in the universe and about the conditions necessary for the development of life. If Earth's large moon played a crucial role in stabilizing our planet's climate and creating conditions favorable for the evolution of complex life, then we might expect that planets with large moons would be more likely to host advanced biospheres. If large moons around terrestrial planets are rare, as they appear to be in our solar system, then perhaps Earth-like planets capable of supporting complex life are also rare, at least in their fully developed form. This line of reasoning connects to the broader question of the frequency of life in the universe and the likelihood that we are alone, or whether intelligent civilizations are common. Some researchers have proposed what they call the rare Earth hypothesis, which argues that while simple microbial life might be common in the universe, the specific combination of factors required for the evolution of complex multicellular life and eventually intelligence is so improbable that Earth might be one of only a handful of such worlds in the entire galaxy. The presence of a large stabilizing moon, the existence of plate tectonics, the location in the habitable zone of a stable star, the presence of a large gas giant like Jupiter to clear out dangerous asteroids, and many other factors all had to align for Earth to become the living world it is today. If any of these factors is indeed rare, then complex life might be correspondingly rare, and we might be far more isolated in the cosmos than we would like to believe. The counter-argument to the rare Earth hypothesis is that life is remarkably resilient and adaptable, and that many of the factors thought to be essential might turn out to be less critical than we assume. Life on Earth has survived multiple mass extinctions, including asteroid impacts that killed off the majority of species, and has adapted to environments ranging from boiling deep-sea vents to the frozen depths of Antarctic ice. Perhaps life could also adapt to planets with chaotic axial tilts, or without large moons, or with very different climatic conditions than Earth, and our view of what is necessary for life is too narrow, too focused on the specific conditions of our own planet. The discovery of life or evidence of past life on Mars, Europa, Enceladus, or any other body in our solar system would dramatically shift this debate, suggesting that life can arise and persist in a wide variety of environments, and that Earth-like conditions may not be as essential as the rare Earth hypothesis suggests. The question of whether the moon is natural or artificial has implications that extend far beyond the realm of science and into the domains of philosophy, religion, and culture. Throughout human history, the moon has held a special place in our mythology and our understanding of the cosmos, and the revelation that it might be an artifact rather than a natural object would represent a profound shift in how we view ourselves and our place in the universe. Such a discovery would confirm that we are not alone, that other intelligent beings have existed and have been capable of engineering on a cosmic scale, and that our solar system, and perhaps even our planet, have been touched by their presence. The psychological and cultural impact of such a revelation would be enormous, potentially triggering re-evaluations of religion, philosophy, and the very meaning of human existence. For many people, the idea that the moon might be artificial is exciting and inspiring, opening up vistas of possibility and wonder that the mundane natural explanation cannot match. If the moon is a monument left by an ancient civilization, then it represents a mystery waiting to be solved, a puzzle that might reveal secrets about who those builders were, where they came from, and what became of them. The search for evidence of artificial lunar structures, whether through telescopic observation, analysis of lunar data, or future exploration missions, takes on a new urgency and meaning, transforming lunar exploration from a purely scientific endeavor into something more akin to archaeology or detective work. Every crater, every unusual formation, every unexplained anomaly becomes a potential clue, a piece of evidence that might finally unlock the truth. However, for others, the possibility that the moon is artificial is unsettling or even threatening, challenging deeply held beliefs about the natural order and humanity's significance. Many religious traditions incorporate the moon into their cosmologies and creation stories, viewing it as part of the divine plan or as evidence of the Creator's handiwork. If the moon turned out to be artificial, it would raise difficult questions about the relationship between these religious narratives and observable reality, potentially requiring reinterpretation or revision of sacred texts and beliefs. While some religious thinkers might embrace the discovery as evidence of creation on an even grander scale than previously imagined, others might reject it as incompatible with their faith, leading to potential conflicts between scientific and religious worldviews. The philosophical implications of an artificial moon are equally profound. If an advanced civilization existed billions of years ago and was capable of constructing or modifying moons, what does that say about the nature of intelligence and the trajectory of technological development? It suggests that intelligence might be far older and more widespread in the universe than we have assumed, and that the path from primitive life to advanced civilization is one that has been traveled many times before. It also raises questions about the ultimate fate of civilizations. Where are the builders now, and what happened to them? Did they transcend physical existence, ascend to some higher plane of reality, or did they simply die out, leaving only their monuments behind? And if they disappeared despite their incredible abilities, what does that imply about humanity's own future and our chances of long-term survival? Science fiction has explored these themes extensively, offering various scenarios for how humanity might react to the discovery of an artificial moon or other evidence of ancient alien civilizations. In some stories, the discovery leads to a golden age of cooperation and enlightenment, as humanity unites to understand and unlock the secrets of the ancient technology. In others, it triggers conflict and division, as different nations or factions compete for control of the alien artifacts, or interpret their significance in contradictory ways. Still other stories depict the discovery as the trigger for catastrophe, awakening ancient mechanisms that were never meant to be disturbed, or revealing truths that humanity is not ready to accept. While these are fictional scenarios, they reflect genuine concerns about how transformative discoveries are integrated into society and how they affect our institutions, beliefs, and sense of identity. The moon's potential role as a witness to Earth's entire history adds another layer to these considerations. If the moon is artificial and contains monitoring equipment or recording devices, then everything that has happened on Earth for the past 4.5 billion years might have been observed and documented. The entire saga of life on Earth, from the first simple cells to the rise of human civilization, might exist as a record within the moon's interior, waiting to be discovered. Such a record would be of incalculable scientific and historical value, offering a complete and objective account of our planet's past. But it would also raise troubling questions about privacy, autonomy, and the nature of our existence. Have we been living under observation all along, participants in an experiment or subjects of study conducted by beings whose motives and methods we cannot fathom? These speculations may seem fanciful, but they are worth considering because they illustrate the stakes involved in the question of the moon's origin. Whether the moon is natural or artificial is not merely an academic question for specialists to debate in journals. It is a question that touches on fundamental issues of meaning, purpose, and our relationship to the cosmos. The search for truth about the moon is part of the broader human quest to understand where we come from, why we are here, and whether we are alone in the universe. Questions that have driven human inquiry since the dawn of consciousness and that continue to motivate exploration and discovery in the modern age. As we look to the future, the question of the moon's origin and nature remains open, and the path to answering it lies in continued exploration, observation, and analysis. New missions to the moon are being planned and launched by multiple nations and private companies, each contributing to our growing body of knowledge about our nearest celestial neighbor. These missions employ increasingly sophisticated instruments and techniques, capable of detecting subtle features and anomalies that earlier missions might have missed. Future lunar landers might drill deeper into the surface, extracting cores that reveal the moon's internal structure and composition with greater precision than ever before. Seismometer networks distributed across the lunar surface could create detailed three-dimensional maps of the moon's interior, definitively determining whether there are any large voids or unexpected structures beneath the surface. Proposals have been made for permanent lunar bases that would allow continuous human presence on the moon for the first time since the Apollo era. Such bases would serve multiple purposes: as platforms for scientific research, as testing grounds for technologies needed for Mars exploration, as sites for resource extraction to support space industry, and as symbols of humanity's expansion beyond Earth. A permanent lunar base would also provide opportunities for more extensive and detailed exploration of the lunar surface, with astronauts able to travel to remote locations, investigate interesting features up close, and conduct experiments that are difficult or impossible to carry out robotically. If there are any signs of artificial structures or unusual phenomena on the moon, a human presence would greatly enhance our ability to investigate and understand them. Advanced telescopes and observational techniques may also contribute to solving lunar mysteries. New generations of ground-based and space-based telescopes are being designed with unprecedented resolution and sensitivity, capable of detecting features and changes on the lunar surface that have previously been invisible. Interferometric techniques that combine observations from multiple telescopes could achieve resolutions fine enough to see objects the size of buildings on the Moon, potentially revealing artificial structures if any exist. Time-lapse photography covering decades or centuries could detect slow changes or movements that individual observations would miss, providing evidence for ongoing activity or processes on the Moon that we have not yet recognized. The development of new analytical techniques for studying lunar samples also holds promise. The rocks and soil returned by Apollo missions have been studied intensively for more than 50 years, but new instruments and methods continue to extract additional information from these precious samples. Isotopic analysis with greater precision might reveal subtle clues about the Moon's formation that have so far eluded detection, while the study of minerals and crystal structures could provide insights into the conditions under which the lunar rocks formed. Small particles and dust grains that were largely ignored in earlier studies are now being examined with electron microscopes and other advanced tools, revealing unexpected complexity and diversity in the lunar regolith. International cooperation in lunar exploration has the potential to accelerate progress and ensure that the benefits of discovery are shared widely. The Artemis program, led by NASA but including partners from Europe, Japan, Canada, and other nations, aims to return humans to the Moon in the coming years and to establish a sustained presence in the lunar vicinity through the Lunar Gateway, a small space station that will orbit the Moon and serve as a staging point for surface missions. China has also announced ambitious plans for lunar exploration, including crewed missions and the establishment of a research station at the lunar South Pole. If these programs can find ways to coordinate and share data, the pace of discovery could be greatly enhanced, and the risk of duplicate efforts or missed opportunities could be reduced. The question of whether to actively search for evidence of artificial structures on the Moon remains somewhat controversial within the scientific community. Most lunar scientists believe that the evidence overwhelmingly supports a natural origin for the Moon, and that deliberately seeking signs of artificiality is a waste of resources that could be better spent on more productive research. However, a minority argues that the potential payoff of discovering evidence of an artificial moon is so enormous that even a small probability of success justifies some level of effort. These researchers advocate for dedicated searches using high-resolution imagery, gravitational surveys, and ground-penetrating radar to look for anomalies that might indicate artificial structures, arguing that the cost of such searches is relatively modest compared to the potential benefits. One intriguing possibility is that future lunar explorers might discover not a completely artificial moon, but evidence that a natural moon was modified or enhanced by an ancient civilization. This middle ground scenario could explain the mixture of natural and anomalous features that characterize the moon, reconciling the geological evidence for a natural origin with the various oddities and coincidences that have fueled speculation about artificiality. Perhaps the moon formed naturally through the giant impact, but an ancient civilization later hollowed out portions of its interior, installed monitoring equipment, or adjusted its orbit to achieve specific objectives. Such modifications would be far more subtle and difficult to detect than a completely artificial moon, but they might still leave traces that careful investigation could uncover. The broader context for the question of an artificial moon involves considering the likelihood of intelligent life elsewhere in the universe, and the implications of the fact that we have not yet detected any clear evidence of such life. Formulated by astronomer Frank Drake in the 1960s, provides a framework for estimating the number of communicating civilizations in our galaxy. The equation multiplies together a series of factors: the rate of star formation, the fraction of stars with planets, the number of planets in the habitable zone per star, the fraction of those planets where life actually arises, the fraction where life becomes intelligent, the fraction of intelligent species that develop technology capable of interstellar communication, and the length of time such civilizations remain detectable. By estimating values for each of these factors, we can arrive at an estimate for the number of civilizations we might expect to find. The problem is that most of the factors in the Drake equation are highly uncertain, and different researchers arrive at wildly different estimates depending on their assumptions. Optimistic estimates suggest that the galaxy might contain millions of technological civilizations, while pessimistic estimates suggest that we might be alone or nearly alone, with only a handful of civilizations existing across the entire galaxy. The discovery of thousands of exoplanets in recent decades has helped constrain some of the factors, confirming that planets are common and that many are located in their star's habitable zone where liquid water could exist on the surface. However, this still leaves the biological and sociological factors largely unknown, because we have no examples of life other than Earth to guide our estimates. The Fermi paradox, named after physicist Enrico Fermi, asks why, if intelligent civilizations are common, we have not yet detected any evidence of them. With billions of stars in the galaxy and billions of years for civilizations to arise and spread, we might expect that at least some civilizations would have developed the technology for interstellar travel and would have colonized or at least visited every corner of the galaxy by now. The fact that we see no evidence of this widespread presence is puzzling and has led to numerous proposed explanations, ranging from the possibility that intelligent life is far rarer than we think, to the idea that advanced civilizations inevitably destroy themselves, to suggestions that they are deliberately avoiding contact with us, or that they exist but in forms so different from us that we cannot recognize their presence. The artificial moon hypothesis, if true, would provide a partial answer to the Fermi paradox by suggesting that advanced civilizations have indeed been active in our region of space, at least in the distant past. The moon would be evidence of their presence, a monument or artifact left behind for us to eventually discover and interpret. However, it would also deepen the mystery in some ways, because it would raise the question of why this ancient civilization left a moon but no other obvious traces, and where they are now. If a civilization was advanced enough to construct or modify a moon billions of years ago, why have they not continued to interact with Earth? And why do we not see evidence of their activities elsewhere in the solar system or the galaxy? One possible explanation, explored in science fiction and speculative science, is that advanced civilizations reach a point where they transcend physical existence or leave the universe entirely, moving into higher dimensions or alternate realities where physical matter and energy are no longer relevant to their existence. From this perspective, the moon might be a relic of a civilization's physical phase, left behind when they no longer needed it, much as we might leave behind old tools or buildings when we move to a new location. Another possibility is that the ancient builders are still present but in a form we cannot detect, perhaps existing as patterns of information in exotic substrates, or as entities that operate on scales of space and time so different from our own that we cannot perceive them directly. Alternatively, the civilization that built or modified the moon might have been just one of many, part of a broader pattern of galactic scale activity that was once common but has since ended for reasons we do not understand. Perhaps the galaxy underwent a period of intense activity billions of years ago, with multiple civilizations arising, expanding, and building megastructures, followed by a period of decline or collapse that left only scattered artifacts behind. Earth might have been one location among many where these ancient civilizations were active, and the moon might be our local example of a type of artifact that exists elsewhere in modified or different forms. If this is the case, then searching for similar structures around other stars or in other parts of our solar system might reveal additional evidence of this ancient galactic civilization. The search for extraterrestrial intelligence, or SETI, has been ongoing for more than 60 years, using radio telescopes to listen for artificial signals from space. So far, no confirmed detections have been made, though there have been a few intriguing signals that generated excitement before being explained as natural phenomena or terrestrial interference. The lack of success has led some researchers to question whether radio signals are the right approach, suggesting that advanced civilizations might use very different communication methods, such as laser beams, neutrino emissions, or even quantum entanglement. Others argue that the search has been too limited in scope and duration, covering only a tiny fraction of the sky for brief periods, and that we need to be more patient and persistent. The discovery of an artificial moon would provide a target for more focused investigation, because if the moon is artificial, it might contain technology or mechanisms that could be used to communicate, or that could provide clues about where the builders came from and where they went. Throughout this exploration of the possibility that the moon is artificial, we have encountered a tension between open-minded speculation and the rigorous standards of scientific proof. Science advances through a process of hypothesis formation, prediction, observation, and testing, with theories being accepted or rejected based on how well they explain the available evidence and how successfully they make predictions that can be verified. The artificial moon hypothesis faces significant challenges in this framework, not because it is impossible in principle, but because it struggles to make testable predictions that distinguish it clearly from the natural formation hypothesis, and because the evidence cited in its favour can often be explained, at least in part, through conventional means. The burden of proof in science rests on those making a claim, especially when that claim challenges established understanding. The natural formation of the moon through a giant impact is the mainstream scientific view because it is supported by multiple lines of evidence, including computer simulations, chemical analysis of lunar samples, and our understanding of planetary formation processes. While this theory is not perfect and has unresolved issues, it meets the scientific standard of being the best available explanation given current knowledge. For the artificial moon hypothesis to replace or supplement this view, it would need to provide equally compelling evidence that clearly points to artificial construction and cannot be reasonably explained by natural processes. Some proponents of unconventional theories argue that mainstream science is too conservative and too quick to dismiss ideas that challenge established paradigms. They point to historical examples where scientific consensus turned out to be wrong, such as the rejection of continental drift in the early 20th century, or the initial skepticism toward the idea that an asteroid impact caused the extinction of the dinosaurs. These examples show that scientific consensus can change when new evidence emerges, but they also illustrate an important principle. The scientists who eventually overturned the old views did so by presenting overwhelming evidence and rigorous arguments that convinced their colleagues, not merely by appealing to open-mindedness or by accumulating anomalies. The accumulation of anomalies is not by itself sufficient to establish a revolutionary new theory. Every scientific field contains unexplained observations and puzzling data points that do not quite fit current models, and researchers work continuously to resolve these mysteries through further investigation, refinement of theories, or development of entirely new frameworks when necessary. Many anomalies turn out to be measurement errors, artifacts of observational techniques, or the result of incomplete understanding that is resolved through additional data. Only when anomalies persist despite intense scrutiny and cannot be accommodated within any reasonable extension of existing theory does the scientific community begin to seriously consider revolutionary alternatives. For the moon, the key question is whether the collection of anomalies and coincidences we have discussed constitutes a pattern that demands a revolutionary explanation, or whether they can be understood as the natural variation and complexity we should expect in any large-scale system. The perfect size match between the moon and sun during solar eclipses is indeed a remarkable coincidence, but the universe is vast and contains countless objects, so some remarkable coincidences are inevitable simply by chance. The unusual size of the moon relative to Earth can be explained by the giant impact hypothesis. Even if the details are still being worked out, the seismic characteristics of the moon are unusual but not clearly impossible for a natural body. The distribution of Maria on the near side can be understood through differential heating or other asymmetric processes, even if the exact mechanism remains uncertain. None of this is to say that the artificial moon hypothesis is definitively wrong or that it should not be investigated. On the contrary, the history of science shows that progress often comes from pursuing unconventional ideas and questioning assumptions, and there is value in exploring alternative explanations even when they seem unlikely. However, investigation must be done according to scientific principles, with clearly stated hypotheses, rigorous methodology, and honest evaluation of results. Claims must be backed by evidence, not just speculation, and researchers must be willing to accept negative results if their hypotheses are not supported by data. The artificial moon hypothesis would be greatly strengthened if its proponents could identify specific predictions that differentiated from natural formation and could propose concrete observations or experiments that would test those predictions. Looking ahead to the next few decades, the moon is poised to become a focus of human activity in space to an extent not seen since the Apollo era. Multiple nations and private companies have announced ambitious plans for lunar exploration, resource extraction, and even permanent settlement, driven by a combination of scientific interest, economic opportunity, and geopolitical competition. China's lunar program aims to establish an international lunar research station at the moon's south pole, potentially in cooperation with Russia and other partners. While NASA's Artemis program seeks to return American astronauts to the lunar surface and establish a sustainable presence that will serve as a stepping stone to Mars, private companies like SpaceX, Blue Origin, and others are developing lunar landers and transportation systems that could make access to the moon cheaper and more routine than ever before. The south pole of the moon has emerged as a particular area of interest due to the presence of water ice in permanently shadowed craters and the availability of near-continuous sunlight on certain elevated ridges, which could provide solar power for lunar bases. Water is crucial for sustained human presence because it can be split into hydrogen and oxygen for rocket fuel and life support, eliminating the need to transport these heavy and bulky resources from Earth. The ability to extract and use lunar resources, a concept known as in situ resource utilization, could dramatically reduce the cost of space operations and make long-term lunar habitation economically feasible. Mining lunar regolith for oxygen, metals, and other materials could support not only lunar bases but also the construction of spacecraft and facilities in lunar orbit or even at other locations in the solar system. These practical considerations of exploration and resource use intersect with the question of the moon's origin and nature in interesting ways. If the moon is artificial or contains artificial structures, these might be discovered during mining operations, construction activities, or deep drilling projects undertaken for practical purposes. A drill bit descending into the lunar regolith might strike an unexpected layer of material, a hollow cavity, or a structure that clearly could not be natural, immediately transforming a resource extraction project into the most important archaeological investigation in human history. Even without such dramatic discoveries, the expanded human presence on the moon will provide vastly more opportunities for detailed observation and investigation than have existed at any time in the past, increasing the chances that any unusual features or anomalies will be noticed and studied. The establishment of lunar bases will also enable new types of scientific investigations that are difficult or impossible to conduct from Earth or from short-duration missions. Long-term seismic monitoring with arrays of sensors distributed across the lunar surface could create detailed maps of the moon's interior structure, definitively answering questions about whether there are significant voids or unusual density distributions beneath the surface. Deep drilling projects could extract cores extending hundreds of meters or even kilometers into the lunar crust, revealing the layered history of the moon and potentially finding materials or structures that formed before the solar system's current configuration. Radio telescopes on the far side of the moon, shielded from Earth's radio noise, could conduct extraordinarily sensitive searches for artificial signals from space, possibly detecting communications or emissions that are too faint to be detected from Earth. The development of lunar industry and infrastructure will require solving numerous technical challenges, from protecting equipment and personnel from the extreme temperature swings between lunar day and night, to dealing with the abrasive lunar dust that can damage machinery and contaminate habitats, to providing power during the 2-week lunar night when solar panels are useless. Nuclear reactors, perhaps using radioisotope thermoelectric generators or small fission reactors, will likely play a role in providing reliable power, while habitats will need to be built using local materials or buried beneath regolith to provide radiation shielding and thermal insulation. The technologies developed for lunar application will have broader uses in space exploration and might even find applications on Earth, contributing to the pool of human knowledge and capability in ways that extend far beyond lunar exploration itself. The economic case for lunar development rests on several potential revenue streams, including tourism, resource extraction, scientific research, and the provision of infrastructure services for missions to other destinations in the solar system. Space tourists might pay substantial sums for the opportunity to visit the moon, walk on its surface, and experience the unique perspective of seeing Earth hanging in the black lunar sky. Mining operations could extract rare elements or compounds that are valuable on Earth or that are needed for space construction but are expensive to launch from Earth's surface. Scientific institutions would pay for access to the unique research environment the moon provides, while space agencies and private companies operating missions to Mars or the asteroid belt might use lunar facilities as refueling stations or staging areas, reducing the cost and complexity of deep space missions. Beyond the mainstream scientific explanations and the artificial moon hypothesis, there exist numerous other alternative theories about the moon's origin and nature, ranging from the relatively plausible to the highly speculative. Some researchers have proposed that the moon might be a fragment of Earth that separated from our planet, not through a single catastrophic impact, but through some other process, such as rapid rotation causing the Earth to spin off a piece of itself, or through electrical or plasma interactions in the early solar system. These theories generally lack the supporting evidence that the giant impact hypothesis possesses, but they illustrate the diversity of ideas that have been proposed to explain the moon's existence. Other theories venture into more speculative territory, suggesting that the moon might have formed in an entirely different part of the solar system, or even in another star system, and travelled through interstellar space before being captured by Earth. Such a scenario would require extremely unlikely circumstances, both for the moon to survive the journey through interstellar space and for it to arrive at just the right time and with just the right velocity to be captured by Earth's gravity. But it is not strictly impossible. If this were true, the moon's composition might show evidence of formation in a different chemical environment than the Earth-Sun system, though current analysis of lunar samples does not support this idea, as the moon's composition is very similar to Earth's mantle. Some alternative researchers have proposed that the moon might be much younger than the standard geological age of 4.5 billion years, citing the ancient myths about a time before the moon as evidence that it arrived in Earth's vicinity only a few thousand or tens of thousands of years ago. This idea faces enormous obstacles from multiple lines of evidence, including the heavily cratered surface of the moon that requires billions of years to accumulate, the recession rate of the moon that can be traced backward to show its formation in the distant past, and the radiometric dating of lunar rocks that consistently shows ancient ages. While it is theoretically possible that all of this evidence could be misleading or misinterpreted, the convergence of multiple independent dating methods makes this extremely unlikely. The hollow moon concept has been extended by some theorists into the idea that the moon might be a spacecraft or ark, a mobile artificial structure that travelled to the solar system from elsewhere and took up residence in orbit around Earth. This scenario would explain the moon's unusual properties by suggesting that it was designed and built as a vehicle rather than as a stationary artificial satellite. Proponents point to the moon's low density compared to what would be expected from a solid rocky body as evidence of a hollow interior, though mainstream explanations attribute this low density to a composition that includes more light elements and fewer heavy metals than Earth. A spacecraft moon would presumably have engines or propulsion systems, and while no obvious signs of such systems have been detected, advocates suggest that they might be hidden, inactive, or operating on principles we do not yet understand. Another speculative idea is that the moon might serve as a repository or archive, a vast library containing the accumulated knowledge and history of its builders. This concept appears frequently in science fiction, with stories depicting lunar explorers discovering ancient data storage systems, holographic records, or even preserved specimens and artifacts documenting the civilization that created the moon. Such a repository would be of incomprehensible value, providing insights into a vanished civilization's science, culture, history, and perhaps explaining what became of them. While there is no direct evidence for such a repository, the idea has a certain appeal as an explanation for why an advanced civilization might go to the enormous effort of building or modifying a moon, to leave a lasting record that would survive long after their civilization had passed away. The enduring fascination with the idea that the moon might be artificial reveals something important about human psychology and our relationship with mystery. Human beings are pattern-seeking creatures, evolved to detect regularities in the environment and to construct explanations that make sense of the world around us. When we encounter something that seems too regular, too coincidental, or too purposeful to be the product of random chance, our instincts push us toward looking for intentional causes, for agents and designers who created what we observe. This tendency has served us well throughout our evolutionary history, helping us to predict the behavior of other humans and animals, and to survive in a complex social and ecological environment. But it can also lead us astray, causing us to see patterns and intentions where none exist. The phenomenon known as pareidolia, where we perceive meaningful patterns in random or ambiguous stimuli, is a well-documented aspect of human perception. We see faces in clouds, animals in constellations, and figures in abstract patterns because our brains are wired to recognize these forms, even when they are not really present. The same tendency might be at work when we look at the moon and see its anomalies and coincidences as evidence of design rather than as the natural variation that occurs in complex systems. The perfect eclipse ratio, the unusual size, the distribution of Maria, and all the other oddities might simply be the result of our pattern-seeking brains highlighting certain features while ignoring the many aspects of the moon that are perfectly consistent with natural formation. However, it is important to distinguish between the psychological tendency to see patterns and the genuine investigation of anomalies. Just because humans are prone to false positives in pattern detection does not mean that all perceived patterns are false. And the history of science is full of examples where initially puzzling observations turned out to be real phenomena requiring new explanations. The key is to apply rigorous methods that can distinguish real patterns from illusions, using multiple independent lines of evidence, statistical analysis, and experimental testing to determine whether an observed pattern is likely to be real or likely to be a chance fluctuation or perceptual artifact. The emotional appeal of the artificial moon hypothesis also plays a role in its persistence and popularity. The idea that we are not alone in the universe, that we have been watched over by an advanced civilization for billions of years, and that humanity might be part of a grander cosmic narrative than we realize, is deeply satisfying on an emotional level. It provides meaning and purpose to our existence, suggesting that we are significant in the cosmic scheme of things and that our development has been anticipated or even guided by others. This emotional appeal does not make the hypothesis true, but it does help explain why it resonates with so many people and why it continues to be discussed and debated despite the lack of definitive evidence. Conversely, the mainstream scientific view that the moon is a natural object formed through random collision might seem cold and meaningless in comparison, suggesting that we are the product of blind physical processes with no inherent purpose or direction. This perspective can be uncomfortable or even distressing for those who seek meaning and significance in the cosmos, and it is understandable that some people prefer explanations that provide a sense of purpose and connection. However, meaning and significance do not require external agents or cosmic designers. They can also emerge from the process of understanding itself, from the realization that we are part of a vast and ancient universe whose workings we are gradually coming to comprehend through observation and reason. The balance between skepticism and open-mindedness is one of the most challenging aspects of evaluating unconventional hypotheses. Too much skepticism can lead to closed-mindedness, dismissing potentially valuable ideas simply because they challenge existing beliefs. Too much open-mindedness can lead to credulity, accepting ideas without sufficient evidence simply because they are appealing or exciting. The ideal approach is to remain open to new ideas while insisting on rigorous standards of evidence, evaluating each claim on its merits rather than dismissing or accepting it based on whether it conforms to our prior beliefs or emotional preferences. This is easier said than done because all of us bring biases and preconceptions to any investigation, but it remains the goal that scientists and rational thinkers strive for. One of the most challenging aspects of the artificial moon hypothesis is reconciling the enormous timescales involved with any plausible scenario for construction or modification by an intelligent civilization. If the moon has been in orbit around Earth for 4.5 billion years, as geological evidence strongly suggests, then any civilization responsible for its creation or modification must have existed in the early solar system, during a period when the sun was newly formed and the planets were still in the final stages of their assembly. This was a violent and chaotic time, with massive collisions reshaping planetary surfaces and the orbits of large bodies still being determined through gravitational interactions. The idea that a technological civilization could have existed and operated in such an environment is difficult to reconcile with our understanding of how life and intelligence develop, which is thought to require stable, long-lived planetary environments. On Earth, life took billions of years to evolve from simple single-celled organisms to complex multicellular forms, and intelligence emerged only very recently in geological terms, appearing in recognizable form perhaps only a few million years ago. This timeline suggests that the development of life and intelligence is a slow process, requiring billions of years of planetary evolution, which would seem to rule out the possibility of an advanced civilization existing in the early solar system before the planets had even finished forming. However, we must be cautious about generalizing from the single example of Earth, because we do not know whether life elsewhere in the universe follows the same trajectory and timeline. It is conceivable that under different conditions, life might arise and evolve much more quickly, or that life might have been deliberately seeded or transplanted from older star systems, giving it a head start on its evolutionary journey. Another possibility is that the civilization responsible for the moon did not originate in our solar system at all, but came from elsewhere in the galaxy, from a star system much older than ours where life had billions of additional years to evolve and develop technology. The oldest stars in the galaxy formed more than 13 billion years ago, soon after the Big Bang itself, and planets around these ancient stars could have hosted life for nearly 10 billion years before Earth even formed. If intelligent civilizations arose on some of these ancient worlds, they would have had an enormous amount of time to develop technology and spread throughout the galaxy, potentially reaching our solar system during its formation and leaving the moon as a marker or tool for purposes we can only guess at. The concept of a galactic-scale civilization, or a civilization that spans multiple star systems, raises questions about communication, coordination, and the maintenance of coherence across vast distances and timescales. Even traveling at a significant fraction of the speed of light, journeys between stars would take years or decades, and communication between different parts of an interstellar civilization would involve delays of years or centuries. How would such a civilization maintain unity and shared purpose across these timescales? Perhaps they would develop forms of consciousness or social organization that are fundamentally different from anything humans have experienced, allowing them to think and plan on timescales of thousands or millions of years without the internal conflicts and fragmentation that seem to plague human societies. Alternatively, an ancient civilization might not need to maintain active coherence at all. They might have sent out self-replicating probes or constructed artifacts like the moon, using automated systems that required no ongoing coordination or communication with a central authority. These artifacts could operate autonomously for billions of years, carrying out their programmed functions long after their creators had vanished or moved on to other concerns. In this scenario, the moon would be a kind of fossil, a remnant of ancient activity that continues to exist not because anyone is actively maintaining it, but simply because it was built to last and has no natural mechanism for decay or destruction. The psychology of beings who think on billion-year timescales is almost impossible for humans to imagine. Our own planning rarely extends beyond our own lifetimes, and even the most long-term human projects, like the construction of cathedrals or the maintenance of religious or cultural traditions, span at most a few thousand years. What would it be like to initiate a project knowing that you will never see its completion, that countless generations will live and die before the project reaches fruition, and that the purpose of the project might not be realized for eons? Such thinking requires a degree of patience and long-term vision that is alien to human nature. Yet if advanced civilizations exist and operate on cosmic timescales, this kind of thinking might be perfectly natural to them. If we accept, even as a speculative possibility, that the moon might be artificial or might contain artifacts from an ancient civilization, we must consider what implications this would have for humanity's future and for our long-term trajectory as a species. The existence of an artificial moon would prove that intelligence can achieve remarkable feats of engineering and can persist or at least leave lasting traces for billions of years. This would be an encouraging sign that civilization is not inevitably self-destructive, and that it is possible to create works that outlast their creators by inconceivable spans of time. It would suggest that the path from primitive life to advanced technology to cosmic scale engineering is a real trajectory that has been followed before, and that humanity might someday follow as well. However, the apparent absence of the moon's builders would also serve as a sobering reminder that even civilizations capable of building moons do not last forever. Whatever became of the ancient engineers, they are not here now, at least not in any form we can detect or interact with. They either died out, left the galaxy, transcended physical existence, or changed so fundamentally that they no longer resemble the beings who constructed the moon. This raises uncomfortable questions about the ultimate fate of civilizations, and whether there are inevitable limits to how long any technological society can persist. Perhaps the same capabilities that allow a civilization to build moons also create vulnerabilities or instabilities that eventually lead to collapse or transformation, and the universe is littered with the monuments of vanished peoples who reached great heights but could not sustain themselves indefinitely. The discovery of an artificial moon would also likely accelerate humanity's own space exploration and development efforts, as governments and private organizations scramble to investigate the lunar interior and to search for similar artifacts elsewhere in the solar system or around other stars. The potential scientific and technological payoffs from understanding alien engineering would be enormous, possibly providing shortcuts to technologies that would otherwise take centuries or millennia to develop. However, such a discovery could also create conflicts and competition, as different nations or groups sought to claim control over access to lunar artifacts or to monopolize the knowledge gained from studying them. International cooperation would be essential to ensure that the benefits of discovery are shared equitably, and that the investigation proceeds in a responsible and systematic manner. For individual humans, the confirmation that we are not alone in the universe and that other intelligences have existed and achieved great things would likely be a transformative experience, changing how we think about our place in the cosmos and our relationship to the unknown. Some might find this revelation inspiring and empowering, a call to action, to reach for our own potential, and to strive to create lasting works that future beings might discover and wonder at. Others might find it humbling or even frightening, confronting us with the reality that we are small and insignificant in the grand scheme of cosmic history. Latecomers to a universe that has hosted intelligence long before us and will likely continue to do so long after we are gone. The question of whether to actively signal our presence to any potential observers or intelligences in the universe would take on new urgency if we had concrete evidence that such beings existed. Currently, humanity broadcasts radio and television signals that leak into space and could potentially be detected by any civilization with sufficiently sensitive receivers, but we have not made concerted efforts to send deliberate messages to the stars. Some scientists argue that we should actively broadcast messages announcing our presence and our characteristics, on the grounds that any civilization capable of receiving our signals would already be far more advanced than us, and thus unlikely to pose a threat. Others argue that broadcasting our presence is recklessly dangerous because we cannot know the intentions of potential recipients, and because history suggests that encounters between civilizations of vastly different technological levels often end badly for the less advanced civilization. If the moon is artificial and contains dormant technology or monitoring equipment, our exploration and investigation of it might serve as a de facto announcement of our technological maturity, potentially triggering responses or activations that were programmed billions of years ago. This is a common theme in science fiction, where human activities on the moon or other bodies awaken ancient systems that then contact their creators or initiate some predetermined sequence of events. While such scenarios remain firmly speculative, they illustrate the point that our actions in space might have consequences we cannot foresee, and that as we venture beyond Earth, we should proceed with both curiosity and caution, aware that we might be entering a landscape shaped by intelligences whose purposes and methods we do not understand. As we near the end of this exploration, it is important to acknowledge the limits of what we can know with certainty about the moon's origin and nature based on current evidence. Despite decades of study, multiple missions to the lunar surface, and the analysis of hundreds of kilograms of lunar samples, significant uncertainties and unanswered questions remain. The giant impact hypothesis, while widely accepted, is still being refined and modified as new data emerges, and alternative formation scenarios have not been completely ruled out. The possibility of artificial construction or modification, while not supported by mainstream science, cannot be definitively excluded based solely on the evidence we've gathered so far. This uncertainty is not a weakness of the scientific method, but rather an inherent feature of how science works. Scientific knowledge is always provisional, subject to revision in light of new evidence or better theories, and the willingness to update our understanding when warranted is what allows science to make progress over time. The theories we hold today represent our best current understanding given the available evidence, but they are not final truths, and future discoveries might require significant revisions or even complete overhauls of our current models. This openness to revision is what distinguishes science from dogma, and what makes it such a powerful tool for understanding the natural world. The difficulty of proving or disproving the artificial moon hypothesis highlights a general challenge in science, which is the problem of underdetermination. Multiple theories can sometimes account for the same set of observations, making it difficult to definitively choose between them based on evidence alone. In such cases, scientists rely on additional criteria like simplicity, consistency with other well-established theories, and the ability to make novel predictions that can be tested. The natural formation of the moon is favoured not because it is the only theory that can explain the observations, but because it is simpler, requires fewer ad hoc assumptions, and fits well with our broader understanding of planetary formation. The artificial moon hypothesis requires additional entities and mechanisms that we have no independent evidence for, and so it is disfavoured by the principle of parsimony, sometimes called Occam's razor, which suggests that we should prefer explanations that require fewer unsupported assumptions. However, parsimony is a methodological principle, not a law of nature, and the simplest explanation is not always the correct one. Reality is under no obligation to conform to our preferences for simplicity, and history contains examples of phenomena that turned out to be more complex and surprising than anyone initially expected. The challenge is to remain open to complex or unconventional explanations when the evidence genuinely requires them, while not abandoning parsimony so readily that we accept elaborate theories without sufficient justification. This balance is a matter of judgment and is one reason why scientific progress often involves vigorous debate and disagreement among researchers with different perspectives and interpretations of the evidence. The question of what would constitute definitive proof that the moon is artificial is worth considering. What discovery or observation would be so compelling that even skeptical scientists would be forced to accept the artificial moon hypothesis? One obvious answer would be the discovery of clearly manufactured structures or materials on or beneath the lunar surface, objects that could not possibly have formed naturally and that show clear evidence of intelligent design. Another would be the detection of active technology, such as functioning machinery, computer systems, or communication devices. A third possibility would be the discovery of a message or inscription left by the builders, explaining their purpose and identity. Any of these findings would be difficult to explain away as natural phenomena and would represent strong evidence for artificial construction. Short of such dramatic discoveries, the accumulation of many subtle pieces of evidence might eventually build a case for artificiality that becomes difficult to ignore. If detailed seismic studies revealed large geometric voids in the lunar interior, if gravitational surveys found mass distributions that seemed structured rather than random, if high-resolution imagery revealed patterns or alignments that could not be explained by natural processes, and if all of these anomalies occurred together rather than in isolation, the cumulative case might become persuasive, even in the absence of any single smoking gun. However, such a case would need to be very strong indeed to overcome the natural presumption in favour of natural formation, and it would need to withstand rigorous scrutiny and attempts at alternative explanation. The question of the moon's origin is intimately connected to the broader question of whether we are alone in the universe, a question that has profound implications for how we understand our place in the cosmos and our future as a species. The silence of space, the fact that we have not detected any clear signals or evidence of extraterrestrial intelligence despite decades of searching, is one of the great puzzles of modern science. If intelligence is common in the universe, if life readily emerges on suitable planets and evolves toward complexity and technology, then where is everyone? Why do we not see evidence of their activities, hear their communications, or detect the signatures of their civilizations? The artificial moon hypothesis provides one possible answer to this question by suggesting that evidence of alien intelligence exists right here in our own backyard, that we have been looking at it all along without recognizing it for what it is. If the moon is indeed an artifact, then the silence of space is not really silence at all. We simply have not learned to recognize the language in which ancient civilizations speak. Their monuments and creations do not look like we expect them to look, do not function in ways we understand, and so we walk past them without realizing what we are seeing. This interpretation suggests that the universe might be full of evidence of intelligence, but that such evidence takes forms so different from what we anticipate that we are effectively blind to it. This idea connects to a concept in astrobiology and SETI research called the Great Filter, which attempts to explain the apparent absence of detectable alien civilizations by proposing that there is some very difficult step in the path from lifeless matter to galaxy-spanning civilization, a filter that most potential civilizations fail to pass through. The filter might lie in the past, meaning that the emergence of life or the evolution of intelligence is extremely rare, and that Earth is one of very few places where it has occurred. Alternatively, the filter might lie in the future, meaning that civilizations regularly arise but almost always destroy themselves or fail to reach the point where they become detectable across interstellar distances. If the artificial moon hypothesis is correct, it would suggest that at least one civilization passed through the entire filter billions of years ago, achieving the capability for cosmic engineering, but the fact that they are no longer present suggests that there might be additional filters beyond the point of technological maturity, challenges that even advanced civilizations struggle to overcome. The implications of the Great Filter for humanity's future are sobering. If the filter lies primarily in the past, and we are in a fortunate position, having already overcome the hardest challenges, and our future prospects for long-term survival and expansion are relatively good. If the filter lies primarily in the future, then we should be deeply concerned, because it suggests that something awaits us that destroys most or all civilizations that reach our current level of development. This could be self-destruction through war, environmental collapse, or technological catastrophe. Or it could be something we have not yet imagined, some inevitable consequence of advanced technology, or some aspect of the universe that becomes apparent only to civilizations that reach a certain level of understanding. Some thinkers have proposed that the Great Filter might not be a single event or challenge, but rather a gradual process of transformation, in which civilizations that reach advanced levels of technology eventually lose interest in physical expansion and exploration, turning inward to explore virtual realities, altered states of consciousness, or other pursuits that leave no detectable traces for external observers. From this perspective, the silence of space does not indicate that civilizations die out, but rather that they transcend the physical phase of existence and become invisible to our current methods of detection. The moon's builders might still exist in some form, but in a mode of existence so different from physical reality that we cannot perceive or communicate with them using any technology we currently possess. Throughout human history, we have told stories to make sense of the world around us, to encode knowledge and cultural values, and to explore possibilities beyond the boundaries of everyday experience. The question of whether the moon is artificial is, in many ways, another story we are telling ourselves. A narrative that allows us to explore themes of ancient wisdom, lost civilizations, cosmic significance, and humanity's place in a vast and mysterious universe. Whether this particular story is literally true or not, it serves important functions in stimulating imagination, encouraging exploration, and reminding us that our current understanding is always incomplete and subject to revision. The human need for narrative and meaning is deep and persistent, and it shapes how we interpret observations and evidence. When we encounter something mysterious or puzzling, we instinctively construct stories to explain it, stories that incorporate our values, beliefs, and assumptions about how the world works. These narratives are not necessarily false or misleading. They can be powerful tools for organizing information and generating hypotheses that can then be tested against evidence. The key is to remain aware that they are stories, mental models that may or may not correspond to external reality, and to be willing to revise or abandon them when evidence points in a different direction. The artificial moon hypothesis functions as a powerful narrative precisely because it connects to so many deep themes that resonate with human psychology and culture. It evokes the idea of lost golden ages, of ancient wisdom and knowledge that has been forgotten but might be recovered. It suggests that we are part of a larger cosmic story, that our world has been touched by intelligence beyond our own, and that there are mysteries waiting to be solved that could transform our understanding of everything. These themes appear throughout human mythology, religion, and literature, from the ancient Greeks' tales of Atlantis to the medieval legends of hidden magical realms, to modern science fiction stories of ancient aliens and forgotten technologies. The popularity of such narratives suggests that they fulfill psychological needs that go beyond simple curiosity about factual truth. They provide a sense of wonder and possibility, a feeling that the world is more interesting and meaningful than the mundane surface reality suggests. They offer hope that problems which seem intractable might have solutions hidden in ancient knowledge or advanced technology. They allow us to imagine ourselves as participants in grand cosmic dramas, rather than as insignificant specks in an indifferent universe. These emotional and psychological functions are valuable in their own right, contributing to human well-being and motivation, even when the literal truth of the narratives remains uncertain. However, there is a danger in becoming too attached to narratives that resonate emotionally but lack empirical support. When stories become dogma, when we insist on their truth regardless of evidence, we lose the ability to learn and adapt, and we risk replacing genuine understanding with comforting illusions. The challenge is to appreciate the value of narrative and meaning-making while maintaining the critical thinking and openness to evidence that allows us to distinguish between stories that accurately describe reality and those that merely satisfy our emotional needs. This balance is not easy to achieve, requiring both imagination and skepticism, both openness to possibilities and insistence on rigorous evidence. As we reach the end of this long journey through the mysteries and questions surrounding our moon, it is time to draw together the threads we have explored and to reflect on what we have learned and what remains unknown. The moon, that pale companion that has hung in Earth's sky for billions of years, continues to hold secrets and surprises, despite centuries of observation and decades of direct exploration. Whether it is a natural satellite formed through a catastrophic collision in the early solar system, or an artificial construct left by an ancient civilization beyond our comprehension, it remains an object of fascination and wonder, a symbol of humanity's desire to explore and understand the universe around us. The evidence we have examined points most strongly toward a natural origin for the moon, formed through the giant impact hypothesis, or some variation thereof. But this conclusion is not without its uncertainties and unresolved questions. The anomalies and coincidences that have fueled speculation about artificial construction are real, even if their interpretation as evidence of design is disputed. The perfect size match during solar eclipses, the unusual proportional size of the moon relative to Earth, the distribution of features on its surface, the seismic characteristics and various other oddities all contribute to the sense that the moon is special, different from other natural satellites in ways that demand explanation. Whether these differences ultimately point to artificial construction or simply to the complex and varied outcomes of natural processes is a question that remains open. The possibility that the moon might be artificial, even if remote, serves as a powerful reminder of how much we still do not know about the universe and about our own history. It challenges us to question assumptions, to remain open to unconventional ideas, and to continue exploring and investigating with curiosity and rigor. The search for truth about the moon's origin is part of the broader human quest to understand where we came from, whether we are alone in the cosmos, and what our ultimate destiny might be. These are questions that touch on the deepest aspects of human existence, and they motivate much of our exploration and scientific inquiry, giving purpose and meaning to our efforts to reach beyond the boundaries of our world. Looking to the future, the coming decades promise to bring unprecedented opportunities to study the moon in detail and to potentially resolve some of the long-standing mysteries about its nature and origin. New missions, permanent bases, resource extraction operations, and expanded human presence on the lunar surface will provide countless opportunities for discovery, and for testing hypotheses about lunar formation and evolution. If there is any evidence of artificial construction or modification to be found, these future investigations stand the best chance of uncovering it. If, on the other hand, all the anomalies and puzzles can ultimately be explained through natural processes, then future research will refine and extend our understanding of planetary formation, demonstrating once again the power of the scientific method to make sense of complex phenomena through observation and reason. As you drift towards sleep tonight, let your mind wander among these possibilities, floating through the silent vacuum between Earth and Moon, imagining what might lie beneath that dusty, cratered surface. Picture ancient machines dormant for billions of years, waiting for the moment when intelligent beings finally develop the capability to recognize them for what they are. Envision vast chambers hollowed out of solid rock, containing records and artifacts from a civilization that flourished when the solar system was young and then vanished, leaving only their greatest monument orbiting a lifeless world that would not give birth to intelligence for eons. Or imagine instead the violent collision that birthed the Moon, the moment when two planets met in a catastrophic impact that reshaped both and created the partnership between Earth and Moon that has endured ever since, shaping our world and making possible the evolution of life and eventually of minds capable of pondering their own origins. The truth, whatever it may be, is out there waiting to be discovered, written in the rocks and craters of the lunar surface, encoded in the gravitational fields and seismic waves that probe the Moon's interior, perhaps even inscribed in messages or markers left by ancient hands for those who would come after. Whether we find evidence of artificiality or confirm natural origins, the search itself is worthwhile, expanding our knowledge and capabilities while satisfying the deep human need to explore and understand. The Moon has been humanity's companion throughout our entire history, inspiring our ancestors, guiding travelers, marking the passage of time, and pulling at the tides that may have helped life emerge from the oceans. Now, as we finally gain the ability to visit that companion world and investigate its secrets directly, we stand on the threshold of potentially revolutionary discoveries that could reshape our understanding of ourselves and our place in the cosmos. Let these thoughts accompany you into sleep, gentle and persistent like the gravitational pull that keeps the Moon in its eternal orbit around Earth. Rest in the knowledge that the universe is vast and full of wonders, that mysteries remain to be solved, and that each generation of explorers adds to the accumulated understanding that is humanity's greatest achievement. The Moon will still be there when you wake, hanging in the sky whether visible or hidden, waiting patiently as it has waited for billions of years, keeping its secrets a little while longer, until we are finally ready to unlock them and to understand the full story of our cosmic neighborhood and the forces, whether natural or artificial, that have shaped the world we call home. And dream of the Moon, that enigmatic guardian of our planet, that possible artifact of the first civilization, that enduring mystery that connects us to the deepest questions about existence, intelligence, and the long arc of cosmic time that stretches from the birth of the universe to this present moment and onward, into a future full of possibilities we can barely begin to imagine.